Assalamualaikum warahmatullahi wabarakatuh. A very good morning, distinguished guests, ladies and gentlemen. It is an absolute pleasure to welcome each of you to the first Universitas Riau International Conference in Science, Engineering, and Technology 2025. Cultivating science, engineering, and technology for sustainable development goals. My name is Salma, and I am very happy to be your Master of Ceremony in this occasion. Her Excellency, Director of Universitas Riau, Professor Dr. Riki MSc. The Honorable Vice Rectors of Universitas Riau, represented by Vice Rector Corporation and Information System, Dr. Sofian Hussein Siregar. The Honorable Deans of Universitas Riau, the Honorable Director of Postgraduate Program Universitas Riau, the Head of Bureaus Universitas Riau, the Head of Institute, UPA and Units Universitas Riau, and our distinguished keynote speakers from Germany, the United Kingdom, Malaysia, and Indonesia. Distinguished guests, ladies and gentlemen. URICSET 2025 focuses on the seven essences in science, engineering, and technology, highlighting innovations and collaboration that support sustainable development goals. Ladies and gentlemen, we kindly invite you to join together in singing the national anthem of Republic Indonesia Raya. Ladies and gentlemen, please rise. begin the event with a blessing. We would like to invite Dr. M. Jaya Adiputra, MPD, to lead us in the recitation of Doa. Please welcome Dr. Jaya Adiputra.
Assalamualaikum warahmatullahi wabarakatuh. Auzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan syakirin, hamdan naimin, hamdan yuafi ni'mahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalalikal karim wa azimi sultan. Allahumma shalli wa sallim ala sayyidina Muhammad wa ala ali Muhammad. Allahumma la tada' lana zamban illa ghafartah, wa la hamdan illa farajtah, wa la daynan illa qadaitah, wa la hajatan min hawaijid dunya wal akhirah illa qadaitah ya arhamar rahimin. Allahumma innaka afuwwun karim tuhibbul afwa fa'fu anna. Allahumma inna nas'aluka salamatan fid din wa afiyatan fil jasad wa ziyadatan fil ilmi wa barakatan fil rizqi wa taubatan qabla al-maut wa maghfiratan ba'dal maut. Allahumma hawwin 'alaina fi syakaratil maut wan najata minan nar wal 'afwa indal hisab. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azaban nar. Walhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor, for the recitation of Doa. Di tungku memasak ikan, harum semerbak di dapur lama. Salam hangat kami ucapkan kepada tamu yang berbahagia. Ladies and gentlemen, the next agenda is welcoming statement from the chair of the organizing committee of URICSET 2025. Please welcome Dr. Zeta Hainul Putra.
Assalamualaikum warahmatullahi wabarakatuh. Good morning. First, I would like to honor Director of Universitas Riau. On this occasion is represented by the Vice Rector of Planning, Collaboration, Systems of the Good morning. And then also I would like to the Chair of Institution, Professor MSc. And I would like to honor the Dean and also the Director of Postgraduate Program and the Chair of Units in University and be joining with us. And I would like to honor the keynote speakers of 4 countries and all participants of Universitas Riau, who are coming from the International Conference of Design Engineering 2025. First, let me praise Allah SWT and also to Prophet Muhammad SAW, so we can hear to participate in this conference. And I would like to thank the international and local committee for running this conference and organize this conference. And I would like to tell that the theme for this conference is cultivating science, engineering, technology for sustainable development goals. And I believe that it becomes a platform for researchers to exchange ideas and experience and engage with leading expert in this area. It will be 4 speakers from different countries. First, Professor Sila joining because still early in the morning from Würzburg University, Germany. The social professor Andres Alus from University of SA, also not ideal because in the middle of midnight. And we have Saudari Yamani Zakaria from University Technology Malaysia is doing with us also. And our special speaker from Universitas Riau, Professor Tire. I think is joining us today. I would like to inform that the conference, will be 58 calls from parallel session, and foreign participant join this conference more than around 12 countries, UK, Germany, Canada, US, also China, and Australia. And this conference, there are five of the conference, including the idea of biology, science, and also interaction with technology and artificial intelligence that become topic right now. We use by many research right now, and also engineering position about the movement, as well biology, medicine, and health. And the last one is academic step. And I would like to request Dr. Sofia to the Vice Rector to open this conference officially. That's the report for this conference. Maybe I wish all participants enjoy the conference. Before the close, I would like to Anton in English. Okay. Number 24 comes for number 25. Right, yeah. Where the mathematicians and knowledge is. Welcome to URICSET 2025, cultivating science, engineering, and technology for SDGs. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor, for the speech. Ladies and gentlemen, the opening remarks and official opening presented by the Rector of Universitas Riau. Education will be delivered on behalf of Rector Universitas Riau by the Vice Rector for Planning, Cooperation and Information System, Dr. Insinyur Sofian Hussein Siregar, MPhil. Please welcome Dr. Insinyur Sofian Siregar, MPhil.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, distinguished guests, esteemed speakers, all respected participants. On behalf of the Rector of Universitas Riau, I am deeply honored to welcome all the first Universitas Riau International Conference Science, Engineering, and Technology URICSET 2025. It is a great pleasure to host the prestigious gathering of scholars, scientists, and innovators from our world. Let us extend to Allah Subhanahu for His blessing and grace that allow us to gather together this many academic event. I would also like to express our gratitude and appreciation to our distinguished keynote speaker, our Professor from Germany, Associate Professor from the United Kingdom, Associate Professor Dr. Yamani Asia, and Professor Dr. Tahir of Universitas Riau, sharing their valuable insight and expertise with us. Your presence greatly enriches the intellectual spirit of this conference. This seminar marks a significant milestone for Universitas Riau through the dedication of its Institute for Research and Community Service (LVBN). It provides a dynamic platform for researchers to exchange ideas, share experience, and engage with leading experts in the field of science, engineering, and technology. The theme of this year's Cultivating Science, Engineering, and Technology for Sustainable Development Goals is timely and highly relevant to the global challenges we face today. Balancing scientific progress, engineering innovation, and sustainability is a shared priority for nations. The pursuit of sustainable development requires more than the preservation of ecosystem. It demands the harmonious integration of science, engineering, and technology to design solutions that solely serve humanity. This components serve as a vital forum to explore ideas, innovations that drive progress toward the sustainable development goal. By uniting science with the technological creativity, we can advance solutions that protect the environment, improve livelihood, and strengthen community relations worldwide. At Universitas Riau, we remain committed to the strengthening our role in global research, collaboration, and innovation, particularly in advancing sustainability, renewable energy, and environmental stewardship. Through platforms such as URICSET, we aim to foster meaningful partnership and generate impactful ideas that contribute to the global knowledge and societal progress. I encourage all participants to actively engage sessions throughout this seminar. The ideas today to meaningful contribution to science, engineering, and technology as towards a more sustainable, equitable, and harmonious future for all. Thank you very much. By saying Bismillahirrahmanirrahim, the first Universitas Riau Internasional Conference is often Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, the Riau is officially open the event. Kindly invite.
Bismillahirrahmanirrahim. Conference is officially open.
Thank you very much, Dr. Sofian, for opening the conference officially. Ladies and gentlemen, honorable guests, we come to the group conversation where all participants will be captured in Zoom screenshot. Participants are kindly requested to turn on their cameras. And also, we would like to invite all the committee to join the conversation on the stage.
Oke, satu, dua, tiga. Oke, boleh berapa? Satu, dua, tiga. Oke.
We would also like to invite all the committee to join the conversation to the stage. Ladies and gentlemen, now we come to the keynote session. We are honored to have two amazing speakers with us at the moment. The first keynote speech will be delivered by Associate Professor Dr. Zaki Yamani Zakaria from University Technology Malaysia. And the second keynote speech will be delivered by Professor Dr. Erman Tahir, MSc, from Universitas Riau, Indonesia. And of course, the session will be led by our amazing moderator, Dr. Shelfia Putri Utami. Now, I would like to hand over the session to the moderator.
Thank you very much, Mrs. Anissa. Good morning, everyone, distinguished guests, respected speaker, ladies and gentlemen. Welcome to the International Seminar, the first URICSET 2025 here in Pekanbaru. We proudly hosted by the Universitas Riau. It's truly an honor and a great pleasure to have all of you with us today, both those attending on site and those joining virtually from around the world. On behalf of the organizing committee, I would like to extend our warmest welcome and heartfelt gratitude to all participants for being part of this academic gathering. Before we proceed, allow me to acknowledge and express our appreciation to our distinguished guests, our rector of Riau, Professor Dr. Sri Indari, SE, which in this event represented by the Vice Rector, and also Professor Dr. Mubarak, Head of the Institute for Research and Community Service, LPPM, Universitas Riau. Thank you very much for your presence and continued support in advancing research and innovation at Universitas Riau. Now, ladies and gentlemen, it is my great honor to introduce our keynote speaker, Associate Professor Dr. Zaki Yamani bin Zakaria, which is the Deputy Director of the Research Management Center at University Technology Malaysia, UTM, and I will also give you a brief CV for him. Dr. Zaki earned his PhD and master degree in chemical engineering from University Technology Malaysia and his Bachelor of Chemical Engineering from the University of Bradford, United Kingdom. His research expertise covered catalytic reaction engineering, process safety, and sustainable energy development. He has led and contributed to numerous national and international research projects, particularly in catalytic polarization, green hydrogen production, and waste to energy conversion. Dr. Zaki has received multiple awards at university, national, and international levels, including the Nali Innovation Award, Inatech Medals, and the Citra Charisma Publication Award from UTM. He is a professional engineer, registered with the Board of the Engineers Malaysia, and a charter engineer under the Engineering Council, United Kingdom. Today, Dr. Zaki will share his insight through a keynote entitled Catalytic Polarization of Petroleum Residue, Transforming Hazardous Waste into Sustainable Energy and Value-Added Product. Please welcome our keynote speaker. The floor is yours. Dr. Zaki.
Thank you very much. Can you hear me, Dr. Sylvia?
Yes, I can hear clearly.
Alhamdulillah. Okay, so Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very briefly, I would like to express our deepest gratitude to the Rector of First Universitas Riau and also the Vice Rector who just officiate. Also, I would like to say hello to my colleague, Dr. Sylvia Putri Utami, who we did our postgraduate together in UTM before, a few years ago. I also forgot when. Alhamdulillah, thank you very much for the invitation. I would also like to address the other keynote speakers who I believe here is Associate Professor Dr. Erman Tahir, as well as our keynote from Germany and also the United Kingdom. So allow me to share my screen. Wait for a second. Share. Share. Okay, I hope you guys can see the screen now. And
yes, we can see the screen.
right, Alhamdulillah.
But
Okay, so
yeah, okay.
okay, so I am given like 30 minutes to deliver the keynote, right?
Yes.
Okay, so I'll start. Okay, thank you very much again. Bismillahirrahmanirrahim. First of all, I am very blessed and deeply thankful for being invited to deliver the keynote for the first Universitas Riau International Conference in Science Technology. And congratulations for having the first international conference. So this is a very spectacular achievement for your university. Alhamdulillah, thank you. And today I would like to deliver some information, some sharing about my research. And this research is about the improvisation or the development of very low value product to something that is going to be very precious. So the title of my presentation here is Catalytic Valorization of Petroleum Residue, Transforming Hazardous Waste into Sustainable Energy and Value-Added Products. So I'm Zakaria, and I'm from the Faculty of Chemical and Energy Engineering. I'm also from the Chemical Reaction Engineering Group. And as mentioned by the moderator just now, I am now the Deputy Director of Research Management Center in UTM. So UTM is not very far from Riau, so I think we can travel by boat, by ferry, and then we can reach. So because I am located at Johor Bahru, it's very close to Riau. To Batam and also to Bintan we can take ferry, but to Riau maybe we can also. Okay, so this is going to be the flow of my presentation. So I'll cover first the project overview, the introduction. I will explain about what is fuel oil blender stock. So fuel oil blender stock later, or I should make it short, it becomes FOBS, F-O-B-S. And also what is the available advanced technology to convert FOBS or to transform FOBS into value-added products. And then there is one kind of technology that is called pyrolysis that I'm going to focus on. The mechanism, the commercialization, future perspective, and also the conclusion. So this is going to be the first part, the project overview of this project that I am working on at the moment. So first I will cover the valorization of FOBS into high-value fuels. Valorization simply means to make the product of higher value. So that is the meaning, the basic meaning of valorization. So if earlier on the product is low value, maybe it costs $5, or maybe it doesn't cost any dollar at all. So it can become $20 or $30 and so on. Okay, and then for the transformation of FOBS into value-added product or fuel, I am going to use catalyst. Catalyst is something that can be used to fasten the reaction. Okay, and then after that, I will talk about the mechanistic and project understanding. So this is going to be the introduction, and we can see that the world is growing with energy. The world is growing with energy, and we cannot live without energy. So if we see here, the total world energy supplies in 2022 is 620 exajoules. 620 exajoules. That's basically 10 to the power of 18 joules. 10 to the power of 18 joules. So that's very, very huge. So we have a global increase up to 1.7% compared to 2021. So and then for the biggest regional increases, we have Asia, which has increased by 4%, China alone 7 exajoules, North America 1.7% increase since 2021. Of course, if we look at 2023, 2024, 25, the value of exajoule will be higher and larger. Okay, so if we see here, what we are using, Asia, that includes us, okay, Indonesia, Malaysia, Singapore, Brunei, and so on. But here, the data here exclude China. So we can see the progress. It has been 73.5 exajoule in 1990 and then escalated to 179 exajoules in 2022, and that is like an increase of 104 exajoule. So that's very, very, very high. And in the world, we are using 627 exajoule up to 2022. Okay, and then if we see here, the breakdown of the energy being used: coal, oil, natural gas, biofuels and waste, nuclear, electricity and heat. And this is the total energy supplies. Okay, we can see, for example, here in Latin America and the Caribbean, by combining 1.6, 14.7 for oil, and 8.4 for natural gas, 6.1 for biofuels and waste, and so on, we can have up to 35.1 total energy supplies, which is 35.1 exajoule for the United States, sorry, for the Latin America. And for the world, it's up to 619 or 620 exajoules. So that's a staggering amount of energy that we are using at the moment. So that comes to the next stage where we have spoken about the global energy, which keeps on increasing, and the fossil fuel dependency. Believe it or not, we in Malaysia and also in Indonesia and most of the part of the world, we are still depending hugely on the fossil fuel, the petroleum. So we can see that rapid growth of global population led to the rise in energy demands, and 80% of energy production sourcing from fossil fuel. So we are still using fossil fuel, but then most countries are slowly, gradually heading towards the renewable energy and what we call mixed energy, mixed renewable energy, and so on. So we need to have that. And what we are having here, so that comes to the second box here: environmental impact of fossil fuel usage. When we use the fossil fuel, the petroleum and so on, of course there will be pollution, because we are going to emit CO and CO2 as well as NOx and so on, because that is going to be the waste after the combustion process takes place when we utilize the energy. So this is going to be a very massive challenge, especially if we want to have a clean environment. And that then comes to the next box, which is the third box here. We know that we have our refinery. Our refinery is processing, our petrochemical refinery we have in Indonesia, in Malaysia, in America, in Europe. But then this petrochemical refinery, although they are producing various types of precious fuel and oil that we want, but at the same time they are producing what we call FOBs, fuel oil bearing stocks, which is a waste. A waste, which means it is a mixture of oils or sludge or tar or bitumen that comes from the processing of the petrochemical in the refinery. So in short, hazardous refinery, we call hazardous refinery byproducts the heavy hydrocarbons C20 to C50 and heavy metals and toxic compounds. Those are the general composition of FOBs. Okay, and we can see that over the year, 45.6 million tons are produced in the world. So that is a staggering number, because it is a waste, and 30% of FOBs contain oil, because these FOBs contain oil because it is still containing carbon and hydrogen, because we are producing this, we are processing this from the petroleum source. So of course there are still carbon and hydrogen and also oxygen that we can use, we can reuse back. Okay? And that's why we are doing valorization of FOBs through catalytic pyrolysis, because we still have the carbon and hydrogen, or let's call it hydrocarbon. This hydrocarbon can be converted into, we can have hydrogen, we can have light fuel oil, we can have methane, we can have gasoline, which is from C5 to C10, as petrol or benzene. Okay? So that's why we are doing this research, and we have been doing this research for the past 6 to 7 years in our lab. We have been doing experimentation and also thermodynamic analysis. Okay, here comes the property of FOBS, FOBS, fuel oil balance stocks. It originates from the waste fuel that we process in the refinery. So the relationship between conventional and unconventional oil. FOBS originates from crude oil, primarily derived from conventional oil sources such as naphtha and other intermediate fractions. So in the refinery, we keep on processing many oils, many types of oils, and the mixture and also the waste oil will be dumped. And this mixture of oil cannot be used anymore because it doesn't have any identity, meaning it's a mixture of many types of waste oil. And usually it will be sent to proper disposal. And for example, in Malaysia, it will be sent to Quality Alam in Malacca, and one drum process of 200 kg, it costs nearly above 2,000 ringgit. Or that is so many million of rupiahs. Okay, so that is only 200 kg, but then the refinery here are processing hundreds or maybe 1,000 plus thousands of tons of fuel oil balance stocks. So these are the things that we need to improve. So if we keep on dumping, it will become environmental issue. If we don't use it, it is a loss because it still has hydrocarbon inside it. Okay, so that's why. But then it's very critical and very difficult. Okay, because this box contains it's very high viscous. It's high viscosity. It has high carbon residue. It contains asphaltene and also a lot of impurities. So if we try to convert this into something that is useful, such as hydrogen, light fuel oil, gasoline, so it's going to be very good. It's going to be profitable. Okay, here some information about FOBS that I would like to highlight. It contains, mainly contains heavy hydrocarbons, asphaltene, heteroatoms. Okay, we have sulfur and nitrogen and metal impurities like nickel, vanadium, iron, and so on. So because of the nature, it's so complex. I mean, it's very complex product and don't have any identity, and that's why the refinery find it difficult and they want to just dispose it away. So if not, previously we conducted an analysis, gas chromatography, to identify what are the components, and that's why we found aromatic resin, asphaltene, and also there are a number of carbon, hydrocarbon, nitrogen, sulfur, and oxygen inside this sample. And we conducted kinematic and viscosity TGA test as well. So we found out that because usually if we want to make it as fuel, we want it to be hydrogen and carbon only. But then when we have nitrogen, sulfur, and oxygen, it becomes more complicated. So this is basically the overview of the compound. Here we have this is the refinery, and in short, this is the refinery, and we keep on processing in the refinery to get gasoline, naphtha, kerosene, diesel, and so on. But then there's the waste coming out, and the waste here is FOBS and also heavy fuel oil. Heavy fuel oil is a subset of FOBS. Okay. Of course, there are also the unconventional heavy products such as extra heavy fuel oil, and sand bitumen. So these are the products that are difficult to reprocess from the refinery. So advanced technology for FOBS includes 6 products. The first we have hydro deoxygenation, where we want to remove oxygen from the FOBS by using hydrogen at high pressure. We also use steam jet, where we steam jet or steam inject the FOBS to get better product from it. Also, we use solvent extraction, but solvent extraction is still quite difficult to be produced in a pilot scale. And then we have this catalytic cracking, where we use catalyst to further crack the FOBS. And we have gasification, where we convert fuel oil waste into C gas by using an oxygen or steam. And finally, we have pyrolysis. This is the thermochemical decomposition of fuel oil waste into liquid, solid, and gas products. And pyrolysis is the act of, we heat the reactor without the availability of oxygen. So it will keep on decompose. So this is a summary of the product produced from previous study. We have hydrodeoxygenation, and it can produce up to 76 or 77 aliphatic hydrocarbon and 32 aromatic. While catalytic cracking, it can produce something good of gas and solid by using catalyst. In this case, a molybdenum catalyst, molybdenum, and we have steam jet, and it can remove the product within 5 minutes by removing 80% of metallic contaminant, the impurities. We can use gasification, and then it can boost out the hydrogen generation, and of course solvent extraction. From solvent extraction, the O-xylene, toluene, and methyl cyclopentene can be recovered. And for pyrolysis, which I'm going to focus here, we can get this in a more economical stage, and we can get gases, solid, and liquid products. And this is going to be the main discussion that I'm going to focus. So why pyrolysis? Because it's quite simple, I can say. Because we put the forks into a ceramic bowl, and then we heat the forks in a furnace, and of course we try as best as we can to eliminate oxygen from there by flowing nitrogen. Okay, and then the feedstock of flexibility the feedstock is flexible enough. It's in liquid or slurry form. High valuable product generation, yes, we can get high valuable product from it. Low cost, yes, we can have it because we just it's a simple setup, and we can just heat it. But then after that, we need to do the separation, but that is also possible, and it is environmentally sustainable. So basically, pyrolysis. Okay, I will define pyrolysis for the sake of those who are not familiar with pyrolysis. A thermal decomposition process that breaks down organic or waste material at high temperature in the absence of oxygen. So basically, we regard forks as an organic material. So it contains many things inside, but then we heat the forks without oxygen. So we can break it down into their respective components depending on the technique. So it converts complex compounds into simpler products such as liquid fuel, gas, and solid. And typically, the pyrolysis can be conducted between 430 to 800 degrees Celsius, causing it to decompose into useful hydrocarbons without combustion. Combustion, we use oxygen, but for pyrolysis, it's without oxygen. So now I'm going to further describe about the pyrolysis. So pyrolysis does require some energy to break down the molecule. Complex molecule in forms. So feedstock is being heated without oxygen, as I mentioned earlier on, and it can produce 3 types of phase: the gases, liquids, and char. And from our experience, we can see hydrogen from our gas chromatography, TCD, GC-TCD, and of course we can see very minimal CO and CO2 being produced from the GC-TCD because there are no oxygen being supplied. So they just use the oxygen that is contained in the forks. So the input heat energy drives the breaking of chemical bonds in the feedstock. And we can see that we have 3 types of pyrolysis, which is slow, fast, and flash. In my process, we use slow pyrolysis because we operate at low heating rates and long residence time because we try to make the reaction up to, at a stage of 20 minutes, 40 minutes, and 1 hour. And we can see the product there. Okay, further on, the upgraded process, catalytic pyrolysis. Okay, we take the forks, we design and we synthesize catalyst, we put the catalyst inside the forks, we heat. And when we heat, the force decomposes into liquid, solid, and gas. And that's where we can see the money. I mean, it's valuable. Okay, so it enhances the version of. This is the enhanced version of conventional pyrolysis. The conventional pyrolysis do not use any catalyst. Okay, so we can also have better control over the product distribution. We can reduce the coke formation and lower the activation energy. So in this case, we are using metal oxide catalysts such as calcium oxide, aluminum oxide, iron oxide. But in our research group, we use nickel ZSA5, and also we use molybdenum ZSA5, and we also use the combination of it. And when I mentioned ZSA5 just now, it's actually a zeolite. So this is actually a zeolite that is made of molecular sieve. So zeolite is basically a type of catalyst that is primarily a combination of establishment of silicon, aluminium, and oxygen arranged in a three-dimensional microporous framework. So it typically, the size is typically 2 nanometer in diameter, and it acts as a molecular sieve, allowing only certain size molecules to interact. So that's it for now. I mean the catalyst, and we can see the difference between the metal oxide catalyst and also the zeolite catalyst. There are differences, but in our case we use zeolite catalyst. We use zeolite catalyst, high acetic acid, promote cracking, aromatization, dehydration reactions, and so on. So there are some precious characteristic of zeolite that we opt because we want to produce specific products. Okay, so here are some of the types of catalysts. We have ZSA5, HZSA5 that we are using in our laboratory. Of course, there are MCN41, beta zeolite, Y zeolite, morganite, and also clinoptilolite catalyst. But then we don't use the other catalyst. So basically, we use the ZSA5 catalyst with silica alumina ratio 30. But then, just to let you know, there are over 250 zeolite catalysts exist globally in the world. So here are some recent studies on zeolite catalysts for the pyrolysis for fuel waste valorization. And in this one, number one, nickel molybdenum ZSA5. This is being studied by my PhD student at the moment. Previously, she was my master student, Anis. Her name is Anis. So she and my other student, then she leads the study whereby we use bimetallic nickel and molybdenum ZSF5 to decompose the long chain complex FOX component into valuable liquid product as well as hydrogen. So so far the study is ongoing, and then we are introducing computational chemistry as well in this study, as well as thermodynamic analysis. Of course, there are other kinds of catalysts like zeolite, Z40, USY, FCC, nickel ZSA5, ZSA5 here, and copper nickel ZSA5, and other dolomite catalysts that is being used to transform FOX into valuable added product as well. So the catalyst synthesis method in our lab, we do impregnation because it's the simplest and commonly used technique for loading active metal into the support, which is the zeolite ZSA5. We introduced the metal, which is nickel and molybdenum, into the zeolite ZSA5 catalyst. Of course, there are a few other methods, which is deposition, reductive deposition, and colloidal method, but we did not use this. But feel free to explore these types of synthesis method. And characterization, we have XRD that we are using to see the crystallinity of the catalyst being synthesized, FTIR to see the functional group, BET to study the surface area, micropore area, pore volume, and so on. Of course, SEM, scanning electron microscopy to see the morphology of the catalyst and also the dispersion of metal catalyst. And there are so many characterizations that we use here that you can see below. Operating parameter, we do control the experiment, the pyrolysis experiment, because it's very important. The temperature we control, the residence times also we control, heating rate, catalyst to feed ratio. This is important because I have not mentioned this before. So we need to control the amount of catalyst to the ratio of feed, the ratio of FOBs. So sometimes when we put the catalyst so little of ratio to the FOBs, it may not work nice, but then if you put so much, so many, it also may not produce what our desired product. So we need to study that as well. So of course we have carrier gas flow rate, which we use nitrogen because it's cheap, so that we can keep the pyrolysis moving, and then we can suppress if there is any oxygen or air inside the system, the pyrolysis system, and also it will push the gases that we produce, in this case hydrogen and maybe some traces of CO and CO2. So here are the products. We have a liquid, gas and solid, as I mentioned just now. For gases, we normally have hydrogen and some CO, some CO2, and sometimes we have our second highest product in the gases is methane. So we can see this in our GCTCD. So this is what this always makes me and my student happy, because we can see hydrogen and also methane, because those are energy. And then we have liquid products as well. But most of the liquid products that we get is like oxygenate. It still contains oxygen, but then it still can be used for other types of application. And for solid, we have char. Char is like only pure carbon, C. Okay, pure carbon, that is the balance of the FOBs that is being heated. So the reaction mechanism, we have cracking, dehydrogenation, decarbonylation, decarboxylation, deoxygenation, hydrogenation, condensation, and polymerization. So those are all 1, 2, 3, 4, 5, 6, 7. All seven reactions are involved in this complex reaction from pyrolysis. In the pyrolysis to produce the three phases of products: liquid, solid, and also gases. And I can't say which one is more important, because the combination of all of these are very important. And here are some examples, not to say example, but here are some clear postulation, because this one is narratively written, so it's so much to read. But here we can see if cracking, so it's simply the removal of the removal of the breaking down of the long hydrocarbon chain. And for decarbonylation, is the removal of oxygen from the hydrocarbon as a CO. So we remove the oxygen as CO. For decarboxylation, we remove the oxygen from the hydrocarbon as CO2, and so on. So there are a few more reactions. And for the last one here, hydrogenation, so it's the removal of oxygen that contains in the FOBs by introducing hydrogen. But this hydrogen we can get from the side reaction that we obtained earlier on, and then it will react, and then the oxygen in FOBs can be removed through as water. So for commercialization, it is a versatile product application. These are among the products that we can obtain, but not only this, okay, because just now I mentioned that we also produce some liquid oxygenate that is useful for many types of application. But then the hydrocarbon range is as shown here. We can have gasoline, naphtha, kerosene, diesel, gas product, in this case hydrogen, and also methane, and solid products, the carbon or the char, that we can use as fertilizer and other applications as well. So for future perspective, we can use this byproduct. We can study and further analyze the byproduct and characterize them, and then use them safely, so that our environment will be safe, because this is also what we want in our SDG. Okay, and then we need to study more intensively in the mechanism by using real data, and that's why we are in the process of employing computational tools. Okay, and then finally we also want to do the integration integrated sustainable approach combine experimental process modeling and life cycle assessment as well as the computational study. So this is what we are doing at the moment. But then we are also looking for collaborators. Inshallah, if there are, then we can work together as well. So I think that makes us arrive to the conclusion. So number one, this force transformation to higher value product can help us to produce sustainable fuel. So we can get hydrogen, we can get gasoline, we can get methane, and many other types of fuel, which is going to be a sustainable approach. So second, it is important to select which catalyst, because by having the right catalyst, we can project to which product that we want. So in our case, in my case, luckily, after doing some preliminary study, our catalyst managed to get hydrogen and methane and also some light fuel. So research gaps and research gaps and future needs. So just now I mentioned that we still need to further study the reaction mechanism, to study intensity thermodynamic and also the large scale and pilot scale and also the computational study. So I think that's it for now. So I would welcome any feedback and also question from all of you, inshallah, so later on. So I hope it will be, the presentation was beneficial, and I pass to Dr. Sylvia Putri.
Okay, thank you very much, Dr.
I hope I managed to deliver in time, in the time required.
Actually, we still have another 10 minutes, but it's okay. But maybe we can compile later, right? Because we have Q&A session together with Professor Edman. Thank you very much. It's very interesting because we are knowing that chemical engineering is about how we can make the product is more valuable and can beneficial to others. Thank you, Dr. Zaki. Maybe next we just goes to Professor Edman Tahir first. Thank you, Dr. Zaki. We will join later in Q&A session. Okay. And now, ladies and gentlemen, we will continue the second keynote speaker, which delivered by one of the professor in Universitas Riau, Professor Dr. Edman Tahir, MSc, from the Department of Physics, Universitas Riau, Indonesia. Okay, I believe he already in our Zoom meeting now. Good morning, Professor Edman.
Ya, selamat pagi.
Selamat pagi. Firstly, let me introduce his curriculum vitae first. Professor Dr. Edman Tahir is a professor of physics at Universitas Riau, Indonesia, where he has contributed extensively to research and innovation in energy, materials, and supercapacitor technology. He obtained his bachelor degree in physics from Universitas Riau, master degree from ITB, Bandung, Indonesia, and doctoral degree in physics from University Kebangsaan Malaysia. Prof. Edman is widely recognized for his pioneering research on carbon-based supercapacitor derived from biomass waste. His innovation, carbon functional supercapacitor cell from areca seed waste, and several related technology have been granted patents and applied in community-based renewable energy initiatives. He has published more than 70 Scopus Index articles in the past few years and has been listed among the world's top 2% scientists by Stanford University and Elsevier in 2024 and 2025. Currently, Prof. Edman continues to lead research on sustainable energy storage material while promoting innovation-based learning and community engagement at Universitas Riau. Okay, let us join his talk with entitled Self-Drop Approach of Solid Organic Waste Derived Nanoporous Carbon for Symmetrical Supercapacitor Briefing. The place is yours, Professor Edman.
Baik, terima kasih Dr. Sylvia. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi untuk kita semua. Bapak Ibu, hari ini saya memang akan presentasi dalam bahasa Indonesia karena semenjak bahasa Indonesia diakui sebagai bahasa internasional, saya salah satu pendukung bahasa Indonesia untuk internasional. dan itu sudah disetujui Pak Prof. Zetra ya. Terima kasih Prof. Zetra ya. Terima kasih juga untuk Dr. Sylvia. Terima kasih juga untuk Ketua PPM ya, Prof. Mubarak dan Pak Wakil Rektor 4 ya, Dr. Sofyan. Dan juga terima kasih semua untuk tim PPM yang sudah sukses menyelenggarakan Universitas Riau Internasional Conference Science, Teknologi, Engineering ya. Sukses selalu, semoga terus berlanjut untuk conference berikutnya. Gitu. Izin saya akan share sedikit PPT yang akan kita ceritakan hari ini. Sudah kelihatan Dr. Sylvia?
Sudah kelihatan, Prof. Mungkin belum di slideshow, silahkan.
Oke, baik. Sudah ya jelas ya?
Baik, ya.
Baik, terima kasih. Hari ini kita cerita memang sedikit dari bagian riset akhir kita ya, tahun 2024-2025 tentang soft-dop approach of solid organic waste derived nanoporous carbon from symmetrical, full symmetrical supercapacitor, a brief review ya. Saya terima kasih juga pada tim saya gitu ya, yang sudah menyiapkan slide PPT hari ini gitu ya. Nah, saya ikut saja apa yang mereka sudah buatkan hari ini. Untuk pribadi terima kasih, Novi terima kasih, dan Sabri juga terima kasih ya. Nah ini kita akan ceritakan lebih kurang 30 menit, mudah-mudahan cukup waktu ya, dan juga mudah-mudahan tidak membosankan. Sebenarnya nanti kami akan cerita bagaimana kami mengembangkan riset superkapasitor berbasis karbon di Universitas Riau, dimulai dari tahun 2013 sampai nanti di akhir-akhir tahun 2024-2025 ya, kita bisa sudah masuk ke bagian self-doping. Artinya memang doping sendirinya dari bahan alam yang ada, kita pertahankan sifat ada kesemula jadian atau sifat ada awalnya gitu ya, dan itu bisa juga memunculkan doping ya, dan itu menjadi nambah ya, atau dapat berguna untuk meningkatkan prestasi kapasitor ya. Bapak Ibu, sedikit saya sampaikan bahwa superkapasitor sebenarnya sama saja dengan piranti penyimpan energi lainnya seperti baterai gitu ya. Dan bedanya adalah kapasitor atau superkapasitor itu tidak mempunyai sifat menyimpan asli. Sebenarnya dia semu gitu ya. Artinya kalau dia tidak dicas, dia tidak menyimpan, tidak mempunyai energi sendiri. Berbeda dengan baterai ya. Tapi punya keunggulan ya, bahwa bisa disediakan dengan murah, biaya murah ya. Kemudian juga relatif aman gitu ya. Dan yang paling penting juga bisa kita buat atau produksi dari bahan-bahan yang ada di Indonesia, khususnya untuk carbon based symmetrical supercapacitor ya. Nah itu yang akan kita ceritakan pagi ini ya. Sini ya. Sini. Oke, baik Bapak Ibu ya, ini kalau kami biasanya kalau kita melakukan penelitian ya, kita punya roadmap ya, dan kami juga akan tunjukkan sedikit roadmap kami bahwa penelitian ini kami mulai tahun 2013 setelah kami pulang dari S3 di Malaysia ya, atau belajar di UGM gitu. Kemudian tahun 2013 itu kami masih bolak-balik UGM juga ya, karena kita keterbatasan peralatan ya, jadi kami bolak-balik melakukan riset ya. Dan kemudian tahun 2015 ya, kami coba kembangkan beberapa alat ya, yang seadanya, sederhana aja, sehingga sebagian kegiatan riset sudah bisa kita buat di tempat kita di Pekanbaru. Dan sedikit hasil sudah bisa nanti kita tunjukkan bahwa mahasiswa kita sudah bisa ikut kegiatan seminar, mungkin seminar nasional ya. Itu tahun 2015. Kemudian tahun 2017 ya, kita coba mengembangkan alat untuk pirolisis ya, instrumen pirolisis ya, dan itu kami coba kembangkan dari bahan-bahan yang ada atau mendapatkannya di Indonesia saja, tidak perlu diimpor ya, sehingga harganya lebih murah dan kinerjanya juga hampir sama kalau kita impor furnace dari luar gitu ya. Harganya mungkin separuhnya gitu ya. Dan kegiatan kita sudah bisa berkembang, data yang dihasilkan juga sudah semakin baik gitu ya. Dan kemudian capaian kita sudah bisa, mahasiswa kita kirim ke konferensi internasional itu tahun 2017 ya. Kemudian ya, master kita berikutnya tahun 2021-2023 kita coba mengembangkan riset hierarchical carbon pulse ya. Riset heteroatom doping prototype 1 superkapasitor ya. Tapi sebelumnya tahun 2020 sebenarnya kami sudah mencoba mengembangkan juga alat untuk pengujian ya. Jadi kalau kita punya produk ya sudah dapat hasil karbonisasi, aktivasi ya, secara fisika dan kimia, kalau tidak ada alat uji kita juga tidak bisa meningkat ke level publikasi yang lebih tinggi gitu ya. Nah tahun 2020 kami dibantu dosen kami di sini Dr. Ramon ya, kita bisa mengembangkan alat Dr. Ramon bantu kami mengembangkan alat untuk pengujian CV ya, cyclic photometry dan juga galvanostatic charge discharge ya. Dengan adanya alat CV dan GCD gitu ya, atau cyclic photometry dan galvanostatic charge discharge ya, untuk kapasitor kita atau superkapasitor kita sudah bisa tunjukkan berapa kapasitansi, berapa energi, ya, berapa daya, gitu ya. Dan juga kita sudah bisa hitung juga berapa tahanan. Gitu ya. Dan kemudian tahun 2021-2023, nah kita mulai fokus pada pengembangan riset hierarchical carbon pores ya. Tadi tahun 2020 riset kita pada nanokarbon, nanostruktur karbon ya. Kemudian tahun 2021-2023 kita pada hierarchical carbon pores ya. Karena hierarchical carbon pores juga mempunyai keunggulan berbeda daripada nanokarbon biasa. Dan kita sudah bisa di sini kita ada prototipe 1 superkapasitor ya. Dan tahun 2024 sampai tahun 2025 kita coba kembangkan lagi prototipe jenis kedua. Dan kemudian juga kita coba buat lagi dibantu oleh tim kami, kita coba buat growth box tool gitu ya. Kemudian juga akan tentu melakukan juga pengujian dengan elektrolit yang bervariasi ya. Selain aqueous elektrolit, kita juga mungkin bisa pada organic electrolyte ya. Dan kami yakin pada suatu waktu atau tahun 2030 ya, nah mudah-mudahan gitu ya, kita bisa mendudukkan sejajarkan gitu ya, atau menggandengkan superkapasitor dengan baterai. Artinya superkapasitor berbasis karbon Indonesia bisa kita sandingkan dengan baterai lithium dan bisa bekerja bersama-sama gitu. Itu cita-cita kami gitu ya. Dan saat ini kami juga disokong oleh beberapa teman ya, dari beberapa universitas, ada yang dari Makassar ya, Unhas juga disokong dari ULM ya, kemudian disokong juga dari kawan kami di Telkom di Universitas. Kita sedang bekerjasama dalam satu konsorsium Riau untuk pengembangan biomasa unggul bagi penyimpanan energi berbasis superkapasitor ya. Dan kami memang optimis, percaya bahwa biomasa Indonesia unggul dan bisa disandingkan dengan bahan untuk produksi superkapasitor ya, yang sejajar dengan bahan-bahan lain gitu ya. Harganya jauh lebih murah. Ini saya singkat saja. Tadi sebenarnya saya juga sudah ceritakan awal riset kita membangun laboratorium ya, bisa berjalan dengan kerjasama hybrid bersama UKM ya, publikasi bersama dengan UKM ya. Ya karena kami belajar di UKM, kita tidak boleh melupakan pembimbing kita yang ada di Malaysia ya. Awal-awal yang mudah untuk bekerjasama dengan alma mater ya. Dan kemudian kita coba lagi ini alat-alat yang sederhana yang kami kembangkan ya, beli dari seadanya, dari riset yang murah gitu ya, dari barbiling sudah seadanya, hydraulic press ya, kemudian hot plate stirrer ya. Dan ini sebelah kiri, sebelah kanan itu alat yang kita buat, di bawah itu servitanya. Awal-awal ya, awal-awal kita mengerjakan riset ini gitu ya. Dan ini capaian-capaian kita ya, itu sudah ada jurnal ya, kemudian ada proceeding ya di seminar-seminar nasional gitu ya. Dan kemudian ini instrumen untuk paralisis yang kami kembangkan ya. Kita juga punya paralisis menggunakan gas inert ya, menggunakan gas CO2, N2, juga kami juga kembangkan juga paralisis menggunakan steam, water steam gitu ya. Dan ini kita kembangkan dari komponen-komponen bahan dalam negeri gitu ya. Harganya murah, kinerjanya juga sama saja dengan apa yang dilakukan orang di luar-luar gitu ya. Dan ini bisa capaian riset kami, bisa kami juga coba membuat juga menggunakan spray gitu ya, agar karbon kita bisa fleksibel ya. Nah ini juga kami coba gitu ya di tahun 2017 juga gitu ya. Kemudian tahun 2017 itu capaian-capaian mahasiswa kita masih dalam konferensi internasional tadi yang kami sudah sampaikan, dan banyak di AIP gitu ya. Nah sekarang ya kita coba usaha, setelah ini kita coba usaha bergeser ke jurnal gitu ya. Tapi memang dimulai dari awal ya, dari nasional, konferensi gitu ya, konferensi internasional gitu ya, dan bergeser selanjutnya gitu ya. Nah tahun 2018 sampai tahun 2020, nah kita coba kembangkan lagi ada pengujian GCG gitu ya, sehingga kita bisa dapatkan pengujian berapa tegangan, berapa waktu untuk cas dan dicas ya, dan juga kita bisa dapatkan informasi berapa tahanan selnya. Dan tentunya luaran atau capaian luaran penelitian kita akan lebih baik ya. Dan ini untuk dipublikasi tentu akan lebih kuat ya gitu ya. Kemudian ini capaian-capaian kami tahun 2018, 2020 ya, macam-macam nanostruktur bahan yang kami laporkan ya. Mulai dari yang sederhana saja nih, bahan-bahan yang ada di sekitar kita, yang ada di Indonesia, yang ada di Riau ya, batang pisang, daun akasia, kulit tikus, kulit jengkol ya, mahkota nanas, sebut pinang, daun akasia ya, dan sebagainya itu. Ternyata kalau kita uji atau kita lihat lebih dalam strukturnya itu ternyata macam-macam ya. Ada nanofiber ya, kemudian hollow fiber juga ya. Hollow fiber dan nanofiber tentu sedikit berbeda, karena dalam bentuk nanofiber itu biasanya seperti pipa atau ya seperti pipa, tapi hollow fiber seperti pipa yang di dalamnya ada lubang ya. Kalau nanofiber pipa pecah ya. Dan ini memberikan apa ya, memberi keyakinan kita bahwa bahan-bahan alam Indonesia itu unggul, dan Allah memang sudah memberikan kita keunggulan dan kekayaan ya. Tinggal kita gali saja ya. Nah dari sini kami dapat laporkan bahwa kapasitas kita dalam tahun 2018 sampai 2020 itu masih dalam rentang 213 farad yang tertinggi ya, kami dapat dari kulit jengkol gitu ya. Dan ranknya memang sudah ada masuk dalam rank kategori atau kelompok super kapasitor ya, karena sudah di atas 100 farad per gram ya. Dan energi itu sudah bisa mencapai yang tertinggi itu 29 watt hour per kilogram. Dan ini memang sudah masuk ke rezim baterai ya, karena baterai itu mulai dari 10 watt hour kilogram min 1. Oke ya. Ini tahun 2020. Dan ini bentuk ya yang tadi kami sampaikan, bentuk struktur karbon nanofiber alami. Dan salah satu yang penting juga kami sampaikan Bapak Ibu bahwa apa perbedaan dari riset kami dengan riset-riset yang dilakukan oleh orang lain ya. Kami mempertahankan bentuk struktur karbon itu saat kita jadikan sel atau kita saat rangkai menjadi sel itu tanpa bahan perekat. Jadi keunggulan karbon tanpa perekat itu akan bisa diangkat atau bisa bisa diteliti lebih luas daripada kita gunakan perekat, karena perekat menyebabkan tutup atau tertutupnya ya, keunggulan karbon kita. Misalnya porinya akan tertutup ya, kemudian mungkin ya sifat-sifat aktif lainnya juga akan ditutup. Ampas ya, ampas tahu gitu ya, daun ketapang gitu ya. Dan ini tadi yang kami sebut hollow fiber ya, ada bagian yang dilingkari itu dia seperti seperti pipa ya. Dan ini juga sangat baik kalau kita pakai untuk elektroda pada bahan dapat berjalan dari dinding luar dan juga akan dapat berjalan pada dinding dalam ya, dari metrik karbon kita ya. Dan ini kalau kita gunakan perekat tentu akan tertutup, akan disumbat gitu ya. Keunggulannya juga akan hilang gitu ya. Dan ini memang selalu kita pertahankan tanpa menggunakan bahan perekat. Ini dapat dari bahan akasia dan jengkol ya. Akasia itu khususnya pada daunnya. Oke, ya. Dan ini kemudian bentuk struktur lain ya, misalnya nanosit ya kita dapatkan juga pada batang ubi muda ya, dan ketapang dan pucuk merah ya. Plus permukaannya cukup bagus di atas 1000 gitu ya. Kapasitasnya juga cukup baik gitu ya. Energinya juga relatif baik. Kemudian struktur karbon yang lain nanosit juga kita bisa dapatkan juga ya. Memang sudah ada, Tuhan ciptakan untuk kita, tinggal kita gali aja gitu ya. Kami dapatkan dari batang ubi muda tadi ya, kemudian pucuk merah dan juga dari daun ketapang ya. Nah, struktur yang seperti ini juga sangat baik karena memang strukturnya seperti lembaran-lembaran ya, sehingga lembaran ini menjadi sangat untuk proses cas dan dicas ion gitu ya. Ditambah dengan struktur kombinasi, misalnya ada kebetulan untuk pucuk merah itu kombinasi dari sheet dan fiber ya, sehingga struktur fiber yang memanjang itu akan menjadi transport atau alat transport elektron, dan tentu juga sebagai transport ion ya, sehingga kita akan dapatkan elektroda yang mempunyai keunggulan dari transport elektron dan ion ya, sehingga menghasilkan kapasitas yang tinggi dan tentu energi juga yang baik ya. Ini tadi tambahan-tambahan bentuk lain yang kami dapatkan juga, misalnya seperti rulang ya, elipse dan kemudian strawberry fiber dan sebagainya gitu ya. Kapasitas relatif baik gitu ya. Ini kita lewat aja gitu ya. Dan ini sebenarnya prosesnya gitu ya. Misalnya daun akasia ya, kemudian nanas ya, kemudian yang lain-lain pandan gitu ya. Kita prakarbonisasi dahulu ya. Setelah kita prakarbonisasi, kita haluskan ya. Kemudian kita aktivasi. Aktivasi kimia kita punya catatan konsentrasi rendah. Karena kalau kita gunakan konsentrasi tinggi, biasanya sifat melekat alaminya akan hilang gitu ya. Dan setelah itu kita buat pelet, kita cetak dalam bentuk pelet seperti koin, dan kita lakukan proses pirolisis ya, menggunakan gas N2 dan CO2 ya, pada suhu tinggi. Dan hasilnya kita dapatkan ini di bawah hasil dari pengujian SEM ya. Memang kita dapatkan struktur fiber ya. Dan sebenarnya sederhana saja ya, misalnya Bapak Ibu melihat daun nanas, habis itu kita korek gitu ya, memang dominan fiber ya. Nah dari situ kita yakin juga kalau kita pertahankan dari kondisi aktivasi gitu ya, artinya selama aktivasi fiber yang tidak hancur, maka struktur fiber itu akan bisa tetap kita pertahankan dan akan kita dapatkan gitu ya. Dan ini menjadi satu keunggulan, bentuk struktur fiber jadi satu keunggulan karena mudah dalam mengantar elektron dan juga mudah dalam mengantar ion ya. Oke, ini capaian-capaian kami lewat aja di sini ya. Kemudian di jurnal-jurnal tahun itu gitu ya, sudah mulai masuk ke ranah Q1 gitu. Dan ini hasil kita di tahun 2023 ya. Karena tahun 2021 sampai 2023 kita sudah pindah ke polihierarki ya. Setelah kita belajar tentang nanostruktur karbon yang kami juga coba menggali bentuk lain dari nanostruktur, tapi pori ya, nanostruktur porinya berukuran nano, tetapi porinya teratur dari besar kecil ya. Secara umum pori itu kalau kita kelompokkan ada pori mikro, pori meso dan pori makro. Nah pori mikro itu artinya ukurannya di bawah 2 nano, pori meso itu ukurannya dari 2 nano sampai 50 ya nano diameter. Kemudian pori makro di atasnya. Kalau kita punya suatu struktur matrik ya, karbon ya, yang mempunyai semua kombinasi pori ini, ada meso, mikro dan makro dan teratur, ini akan menunjukkan satu keunggulan yang berbeda untuk bahan sebagai penyimpan atau elektroda karbon ya. Contoh sederhana aja Bapak Ibu ya, kalau kita di rumah itu mencuci piring dan kita punya spon ya gitu ya, kita letakkan air di permukaan meja cuci piring kita, kemudian kita geser spon ya, mesti airnya hilang, artinya airnya diserap gitu, masuk mudah ke dalam pori gitu ya. Dan ini yang kita coba melakukannya, menggeser kita dari nanostruktur ke nanopori struktur tapi hierarki gitu ya. Karena hasil-hasil yang kami dapatkan cukup bagus ya, kapasitas pun sudah bisa kita tingkatkan. Kita bisa dapatkan sampai lebih dari 400 farad per gram pada daun pisang ya. itu juga kita dapatkan vita 300 dari daun belimbing dan sebagainya gitu ya. Pola pikirnya begitu. Dan bagaimana kita memilih bahan sebenarnya ya? Nah, ini penting juga nih. Ini kira-kira bentuk nano hierarki, misalnya itu yang sebelah kanan itu daun pisang ya, sebelah kiri itu bambu gitu ya. Dan kemudian ini yang lain-lain, misalnya kulit ubi kayu ya, daun belimbing gitu, daun kelor, jahe merah sama asam kades ya. Nah kalau Bapak Ibu lihat, ada juga daun lengkuas ya. Ini sepertinya bumbu dapur di rumah aja gitu ya. Ya memang gitu kayaknya gitu ya. Memang seperti itu yang nampak gitu ya. Dan ini kenapa ini jadi menarik ya? Karena logikanya sederhana Bapak Ibu ya. Bahan-bahan ini ya, seperti lengkuas, ya, asam kandis, ini bahan-bahan yang mempunyai bau gitu ya. Jadi saat kita bau tentu disebabkan oleh gas yang terlepas ya. Saat kita lakukan proses karbonisasi dan aktivasi dalam suhu tinggi, gas yang terlepas ya, kemudian meninggalkan rongga berupa pori yang teratur ya. Dan pemikiran itu yang kami gunakan ya, sehingga kita bisa dapatkan bentuk-bentuk bahan-bahan. Kalau kira-kira kalau dia berbau, kemungkinan ini hierarki pores gitu ya, sehingga ini bisa dikembangkan menjadi elektroda dengan struktur hierarki gitu ya. Itu pola pikirnya sederhana ya, pola pikir dapur rumah saja gitu ya. Ini ya prosesnya sama saja seperti yang tadi sudah kami lakukan, misalnya daun pisang gitu ya. Nah, ini kita uji ya. Ini di bawah ini gambarnya ditampilkan, dibantu oleh tim kami, sudah di lampu tuh tadi ya, lampu LED gitu ya. Ini dari daun pisang. Jadi dalam 400 parat tadi sudah kita bisa yakin itu bahwa kita bisa pakai untuk storage gitu ya. Dan ini kami memang sangat yakin gitu ya, dan memang sudah kita dapatkan gitu ya. Kemudian yang lain ya tadi juga ini campur. Nah kemudian di samping bentuk yang hierarkis ya, ada situs aktif ya, karena memang karbon-karbon dan rantai karbon yang terputus tadi sudah maksimal, sudah cukup banyak dan tetap tanpa prokat ya, maka situs aktif itu akan mudah berikatan atau mudah mengikat yang lain-lain ya, misalnya mengikat U, P, ZN dan sebagainya. Dan ini yang kebetulan yang kita maintain dari awal atau kita pertahankan, sehingga menghasilkan keunggulan lain dari satu piranti kapasitor ya. Kalau murni karbon saja biasanya itu hanya menghasilkan sifat double layer, atau murni dari perpindahan ion dan mata yang itu kita sebut double layer kapasitor. Tambah dengan doping ya, doping akan menghasilkan tambahan sifat pseudo kapasitan ya. Nah dengan mempertahankan karbon hierarki, kemudian mempertahankan tanpa perekat, maka keunggulan karbon itu akan lebih bisa dimaksimalkan ya, termasuk doping alami gitu ya. Dan ini dopingnya tidak kita tambahkan dari luar, tapi doping yang sudah ada dari bahan yang memang kita punya secara alami yang sudah Allah berikan kepada kita gitu ya. Dan ini menjadi satu keunggulan dari pencapaian-pencapaian kami, dan ini tentu dengan mudah atau bisa kita laporkan pada level-level yang lebih tinggi gitu ya. Nah ini tadi pola pikirnya latar belakang hierarki tadi dan doping ya. Kemudian ini macam-macam doping yang bisa kita pakai gitu ya. Ada O, SI, CLF, P, S, N dan P. Biasanya bahan-bahan ini pada tegangan tertentu kalau kita lakukan proses cas dan discharge itu akan meningkatkan arus cas dan arus discharge ya. Saat arus meningkat, arti kapasitas juga meningkat gitu ya. Kalau memang dari bahan semula ada yang ini bisa kita pertahankan, dan tentu akan menjadi keunggulan bagi sel kita ke depannya gitu ya. Dan pola pikirnya sederhana saja ya. Misalnya bahan bahan N gitu ya. Ini tentu bisa kita dapatkan dari palawija. Palawija itu artinya apa? Tanaman yang rutin dipupuk. Ada N, ada P, itu juga ada K ya. Pupuknya apa? Pupuknya itu namanya NPK gitu ya. Ya kira-kira gitu Bapak Ibu, pola pikirnya sederhana gitu ya. Dan ini proses doping ya, yang ada sebenarnya doping dibuat, dan ada juga doping yang sengaja kita pertahankan ya. Itu kita sebut self doping heteroatom ya. Dan kalau kita tambahkan itu artinya doping yang ditambahkan ya. Dan kami mempertahankan cara yang di atas dengan latar belakang karbon tanpa perekat gitu ya. Dan juga pori yang hierarki pos ya. Kalau tidak dia dopingnya tidak optimal gitu ya. Jadi memang apa ya, risetnya berkembang ya, mengalir saja demikian gitu ya. Sehingga di akhir-akhir ini memang kita sudah banyak bekerja pada doping yang soft doping ini gitu ya. Ini saya lewat aja ya. Memang soft doping tadi memberikan peningkatan prestasi pada kapasitor ya, dan dia sudah bisa mendekati ya, bergandengan dekat dengan baterai gitu ya. Dan kami yakin satu waktu nanti yang karbon yang merah itu bisa lebih naik ke atas lagi gitu ya. Energinya juga, daya juga masih bisa kita pertahankan ya. Dan kita yakin dia bisa duduk berdampingan gitu ya. Ini capaian-capaian kami tentang doping tadi ya, maksudnya ya. Dan ini rangkuman-rangkuman ya, capaian ya. Ini juga salah paper-paper kita juga ya. Ini yang kita pernah publish juga nih ya. Yaitu ya, ini juga sama ya. Tadi yang sudah kami rangkum juga ini detailnya. Oke gitu ya. Nah ini sama prosesnya sama mirip tadi ya dengan yang tadi ya. Tapi ya doping ya kita pertahankan ya. Misalnya di sini ada doping ZN, ada CL, ada U gitu ya. Dan kapasitasnya tentu akan meningkat ya. Oke, ini, nah ini prototipe sel kami gitu ya. Kemudian ini yang kita dapatkan tahun 2024-2025 ya, paper kami. Ini yang soft doping ya. Ini dari bahan daun pala ya. Bentuknya campuran dari nanofiber ya. Dan ini secara umum yang kami review yang dalam paper yang kami kirimkan ke panitia ya, ada dari kelapa ya, ada dari lekuas ya, ada akasia pot juga ya gitu. Kemudian sama cara prosesnya lebih kurang sama ya. Dan ini hasilnya data-data bahwa memang ada unsur tambahan ya dari data IDS ya. Yang di sebelah kanan data pengujian sel ya. Dan ini kapasitas didapatkan ya. Kapasitasnya relatif sudah baik ya, di atas 300 ya. Dan ini tentu sangat berperan dalam meningkatkan prestasi kapasitor yang kita dapatkan ya. Ini berapa tulisan kita tahun 2024, 2025 ya. Ada beberapa paper ya. Dan ini mahasiswa kita yang membantu kita selalu di lab ya. Ya sudah ada lumayan ada ya. Kemudian ini proyek kami terbaru ya, tahun 2025 kita dari KUB ya. Kemudian 2025 juga ada fundamental dan selanjutnya tahun 2024 ya. Ini mitra kami di Indonesia, mitra luar negeri nggak kami tuliskan ya. Sebenarnya ada juga beberapa mitra luar negeri. Mungkin itu Bu Sylvia yang bisa saya sampaikan dalam waktu setengah jam ya. Terima kasih ya. Saya tutup kembali ini.
Baik, terima kasih banyak Prof. Arman Taib terkait materi yang diberikan superkapasitor dari biomas ya. Baik, kita mungkin akan masuk ke sesi Q&A ya. We would like to ask Dr. Zaki to join us with today. So, ladies and gentlemen, okay, you're already here. We will move to the question and answer session. So this session is open for both our keynote speaker, Dr. Zaki, and also Prof. Herman, or to both speakers, so you can ask the question for special keynote speaker, or maybe you can ask for both speakers. Okay. So for participants here on site, this session our team will assist you on. For those joining online on Zoom, you may write your question in the chat box, or you can use the raise hand and our team will help you to facilitate. So we will take several questions as this below. The floor is now open for question. Is there any question for both speaker? Ada pertanyaan untuk speaker kita pada hari ini? Silahkan. Ladies and gentlemen dan ibu sekalian. Maybe until we wait the question first. I would like to the valorization products. You mentioned about the catalyst that you use in the process. So have you after you study all the characteristics of the catalysis for catalyst, do you find that significant characteristics for catalyst used for valorization process to increase the AOB product? Such as you mentioned that gas product, right? So what kind of significant for the catalyst to increase the hydrogen gas or something?
Okay, thank you for the question. Saya fikir tadi harus bahasa Indonesia bisa.
You can use
Jadi alhamdulillah terima kasih atas soalan Putri. Okey, jadi kita bikin di kita develop laboratory. Ini sudah saya develop. Jadi mungkin sudah saya ada di sini. Anis namanya. Okey, jadi di develop azure light campur dengan nickel, dan setelah siap kita characterize XRD, extra diffraction, VAT, untuk surface area, TGA kita check. Itulah ketahanan temperature ni. TPD ammonia saya tidak bahas dengan detail. TPD ammonia lihat acidity to see the acidity of this. So we need to make this more acidity side so that it can favor our product. Jadi ini lagi FDI Fourier transform to see the functional group. Of course we have sama seperti Prof. Irman banyak betul sebenarnya bagus lah. Jadi kita send morphology HNS carbon, hydrogen, sulfur, and hydrogen to see. Jadi untuk kita analisa produk yang pertama gas. Kita gunakan actually we have gas chromatography, thermal detector, flame ionization TCD, FID. So maksudnya TCD itu gas, FID flame ionization itu kabel. Jadi di situ langsung dari daripada reactor itu kita directkan ada salur tube masuk ke GC terus dan di situ kita ada empat detector terus dan bukan dua detector empat kolom molecular sieve dan sieve yang jadi kita boleh lihat jadi gas boleh lihat jadi hydrogen dan methane biasa ada banyak tapi CO itu kurang. Jadi kalau memang gas memang langsung kita boleh tapi kalau liquid ada liquid dan liquid itu kalau kita analyze liquid product itu ada a few ada banyak lah kita harus GCFID analytical theory. So antara liquid product yang kita dapat siloxane, octasiloxane, aromatic, naphthalene, biphenyl, S-naphthalene. Jadi ada banyak naphthalene, produk naphthalene yang kita boleh gunakan untuk produk yang lain. Cuma our focus here is the liquid product at the moment. We are focusing on the gases. Tapi ada juga gunakan kategori yang lain. Di sini dapat hydrocarbon yang range daripada 5 ke 10, dapur si kerosene si 15, tapi tak banyak, itu kurang. Jadi itu kita harus develop catalyst yang betul tujuan itulah. Kalau solid char itu ada char, tapi kita tak analyze detail, because mainly kita mau gases product. So I hope I am answering you, Dr. Surya.
Yeah, I think that yes, Dr. Zaki is okay. So focusing on ini ya, gas ya, TCD, so using TCD FID, so characterized by TGA. Kita ada pertanyaan nih dari Dr. Dian Iriani ya, KSN. Ya, pada Ibu Dr. Dian, waktu dan tempat Ibu, silakan Ibu please give your question to the both speaker. Which speaker? Maybe you can. Ya, silakan Ibu.
Okay, thank you very much for Putri.
Ya,
yes,
Mau depan aja masuk, cepatin aja itu.
I think maybe there is some okay. Suaranya tidak terdengar.
Okay, thank you very much for Dr. Putri.
Yeah,
nice presentation from both of our keynote speaker for this morning. So I have a question for both of them. For the first, for Prof. Arman Tahir. So this is very nice, about the sort of carbon, because of Prof. Arman in bahasa Indonesia. So my question also in Indonesian language. Tadi ada banyak ini sumber-sumber karbon, dan tadi dari limbah yang tidak termanfaatkan, bahkan sampai dari kulit jengkol gitu, jadi nggak terpikirkan ternyata pemerintah sudah menjadikan sebagai sumber kapasitor gitu. Sampai juga tadi daun pisang ya, jadi tergantung juga dengan porinya tadi kata Herman. Nah pertanyaannya, bagaimana sih metode self-lopit itu jika kita bandingkan dengan metode konvensional yang sudah ada sekarang ini gitu, apakah ini bahkan sama atau sudah melebihi dari metode yang sudah dikomersialkan atau metode konvensional sudah ada hingga sekarang ini gitu. Oke, itu untuk Bapak Arman Tahir. Nah kemudian untuk Prof. Zaki tadi actually the catalytic valorization of petroleum residue can significantly reduce the hazardous waste, right? So could you elaborate on how the catalytic mechanism specifically contribute to minimizing environmental impact compared to conventional disposal methods? And considering the environmental benefits, what are the main barrier to scaling up this catalytic process to industrial waste, industrial levels, and how can collaboration between academic and industry help overcome these challenges? I think that's all from me. So thank you.
Thank you, Dr. Dian. Maybe Prof. Arman can answer plus the question.
Ya baik. Terima kasih Dr. Dian ya. Terima kasih juga Ibu Sylvia ya. Sebenarnya setiap riset kita itu ada sejarahnya juga gitu ya. Nah, saya cerita dongeng sedikit ya, mungkin ada kalau masih diberi waktu ya. Bagaimana kita awal-awal meneliti daun pisang gitu ya. Itu sejarahnya sederhana. Saat kita pernah beli nasi padang, Bapak Ibu ya, tahu nasi padang ya. Kemudian harusnya dimakan siang, kelupaan ya, dimakannya besok pagi gitu. Ternyata nasi padangnya nggak berubah itu. Nanti nasi padangnya masih cantik tuh ya, masih harum juga gitu ya. Dan kita yakin ada sesuatu di kulit pisang karena nasi padang itu dibungkus dengan daun pisang gitu ya. Dan kita telepon mahasiswa, tolong mahasiswa dicek nih daun pisang ada apa gitu ya. Ternyata sifat serapnya luar biasa. Udara yang diserap, kemudian air yang diserap gitu ya oleh daun pisang menyebabkan nasi padangnya tetap baik sampai besok pagi. Dan itu kami lakukan pengujian untuk daun pisang, memang kita dapatkan hasil yang bagus sekali sampai 400 per gram ya. Dan ternyata dengan cara tanpa perekat tadi gitu ya, keunggulan sifat pori dan keunggulan sifat tambahan seperti doping yang ada itu bisa dipertahankan ya. Dan kalau ditanya tadi oleh Dr. Dian apakah sebanding dengan proses yang ada gitu ya, yang pertama pasti dia lebih murah karena kita tidak menambah biaya doping dari luar. Nah, murahnya ini menjadi satu keunggulan ya. Tapi prestasi yang didapatkan sampai 400 farat itu sejajar dengan yang sudah didapatkan orang dengan cara tambahan doping dari luar. Begini gitu Dr. Dian, begitu juga Ibu Sofia, terima kasih.
Baik, terima kasih banyak Prof. Herman. Maybe the second question for Dr. Zaki.
Okay. Thank you very much Dr. Dian atas soalannya. Jadi tadi ada satu soalan, sudah kalau bahasa Inggeris saya suka bingung. Okey, jadi kalau dibandingkan waste of the petroleum refinery residue itu kan ada banyak. Jadi tadi saya sudah mention namanya FOX, fuel oil blended stock, campuran-campuran daripada banyak waste chemical, waste of fuel being processed. Also being called heavy fuel oil. Jadi dalamnya terkandung banyak-banyak macam-macam lah. Ada sulfur, ada nitrogen, ada vanadium, ada nickel, ada sludge, ada cyclic itu seperti yang benzin, ada ring kan. Jadi that's all very dangerous. Kalau kita sentuh itu sangat bahaya. Jadi memang kalau ikut peraturan memang harusnya dihantar ke waste management, need to have proper waste management disposal. Ya, jadi itu sangat mahal. Jadi biasanya refinery tak ada yang seperti itu. Dia akan hantar ke tempat lain, a more dedicated place. So what the refinery does is actually they need to put in drums and then send to a place where it's more suitable to be disposed. Dan cara untuk dispose itu mungkin ada teknik-tekniknya yang tersendiri, tapi saya bukan fokus saya di situ lah. Jadi itu that's the technique of the waste disposal center, and of course they have the facility. Okay, so in my context, in our context, our research context, fuel oil blended stock or FOBS yang kita gunakan itu kita ambil. Jadi kita ambil, kita letak di dalam satu bekas, dan di dalam bekas itu masih ada impurities itu. Jadi sulfur, nitrogen, nickel masih ada juga. Tapi kita kan subject kepada high temperature. And when we subject to high temperature, it will pyrolyze. The pyrolysis reaction will take place. And when the pyrolysis reaction takes place without the existence of oxygen, tiada air ataupun udara tak ada, oksigen pun tak ada, makanya reaction itu bisa berlaku. Dan reaction itu bisa berlaku dengan lebih cepat, lebih pantas dengan kehadiran catalyst, mungkin catalyst. Bila itu berlaku, because it's already very volatile, mudah untuk meruap, okay, so it vaporize and then it will become its own free radical. Jadi kestabilan, the stability of all the compound or species is not high, so meaning it's not very stable. So it will dissociate, dia akan terpecah-pecah menjadi komponen-komponen yang lebih kecil dan mencari masing-masing komponen untuk bergabung supaya menjadi lebih stable. So itulah terjadinya ada methyl radicals, H3 star, H star, hydrogen radical dan macam-macam radikal yang lain. Jadi dia naik inside the reactor dan dia bergabung, mungkin hydrogen akan bergabung dengan hydrogen radical, jadi menjadi hydrogen lebih stable. Ataupun dua molekul hidrogen bergabung dengan oksigen, trace of oksigen yang ada di dalam FOBS, menjadilah air, water. Dan reaction itu meninggalkan few impurities that cannot react. Jadi contohnya mungkin sulfur, nitrogen, nickel, they are more have more higher boiling point, dan mungkin dia tak dapat nak react, tak jadi volatile, tak menjadi radical. Jadi dia akan tersimpan di dalam FOX itu, masih tersimpan dalam FOX, dan proses berlaku, dan FOX itu masih kekal seperti itu. Dan tapi apa yang boleh terkeluar, gases yang terkeluar akan jadi gas H2, CO, CO2, methane. Liquid boleh terjadi naphthalene, boleh jadi different types of liquid lain. Tapi barang-barang chemical yang bahaya itu seperti nickel, vanadium, dan yang lain-lain itu akan kekal di dalam FOX, dan menjadi char, menjadi solid char. Jadi itu yang kita belum analyse lagi, tapi we believe it still contain inside there, because our analysis di dalam GCFID untuk liquid product dan juga GCTCD untuk memang tidak menampakkan komponen-komponen ini. Jadi kita percaya bahawa we believe that all the heavy metals and other things that is very dangerous remain in the char, which solidify. Jadi FOX itu solidify jadi char, dan tersimpan di dalam itu. Jadi mungkin itu perlu further treatment, ataupun kalau nak dibuang pun okay. If you want to dispose also okay, because it's already being we already extract the important part, the important compound. So the hydrogen, hydrocarbon, we already take it out. So mungkin dia akan jadi more compressed dan mungkin lebih jimat untuk di-dispose, dan dia akan membantu untuk mengurangkan environmental issues lah. Itu soalan yang pertama. Minta maaf panjang sekali jawapannya. Okay, yang kedua, scale up. How can we collaborate with industry to scale this up? This is a very good question, and I am also planning to scale this up lah. Jadi kita itu mendapatkan FOX tu daripada satu refinery, petrochemical refinery di Johor, di Pasir Gudang lah specifically. Dan insyaAllah kalau boleh, mungkin kita bersedia untuk bekerjasama dengan mana-mana refinery, tak kira lah, maybe di Johor, Malaysia, atau di Indonesia mungkin, atau di mana-mana ni, okay, untuk kita dapatkan lebih banyak sampel FOX, dan juga heavy fuel oil. Dan we are planning to develop a bigger pilot scale yang mungkin boleh accommodate lebih banyak FOX. Tapi so far we have not designed the reactor in such way that it is continuous. Masih batch system lagi. Tapi that one is still in process, and we still need to do further research untuk menjadikan ia pilot scale. Tapi mungkin kalau ada teknologi, ada yang ada funder. Jadi yang pentingnya sekarang masalah wang ni, grant. Kalau ada wang, kita bisa fabricate, bisa bikin jadi lagi besar. Jadi mungkin boleh buat semi batch pun mungkin juga. Tapi itulah maksudnya kita masih ada limitation itu. Tapi planning itu ada untuk jadikan dia pilot scale dan terus propose to the industry so that they don't have to waste millions of dollars untuk dispose the FOX. While because we can valorize, we can upgrade the FOX to be energy, fuel and so on. So I hope that answers Dr. Dini, Dr. Diam. Terima kasih Dr. Diam atas waktunya.
Okay, thank you Dr. Zaki, Dr. Dian, for the question and for the answer, also for Professor Arman Tahir. I think I believe we still have time for Q&A session. Maybe for one last question. If anyone would like to ask, please raise your hand in Zoom. If any. Anyone? Or maybe on site? Is there any question? Okay, I think that's all. for today's keynote speaker. Okay, that's all. Thank you, Prof. Herman Tayer and also Dr. Zaki, and also for all participants for your excellent question and also active participants on site and online. Our sincere appreciation also goes to Associate Professor Dr. Zaki Yamani Zakaria and also Prof. Dr. Herman Tayer for their insightful presentation and valuable discussion today. Ladies and gentlemen, that's conclude our keynote session for today. We hope the knowledge share will inspire further collaboration and innovation in the future. Now, I'm pleased to hand the session back to our Master of Ceremony, Ms. Anissa, to proceed with the next agenda.
Thank you very much for the moderators and also the speakers. So ladies and gentlemen, to our sincere gratitude for their inspiring presentation, we would like to present the certificates of appreciation to our distinguished keynote speakers as well as the moderators. Their certificates will be displayed on the screen as a token of our appreciation. Now, for the first certificate is presented to Associate Professor Dr. Zaki Yamani Zakaria from University Technology, Malaysia. Next, the certificate is presented to Professor Dr. Herman Tayer, MSc from Universitas Riau, Indonesia. And finally, the certificate of appreciation is presented to our moderator, Dr. Shelfia Putri Utami.
Thank you very much.
Thank you very much to all of our keynote speakers and also the moderator. Before we move on, we invite all the keynote speakers as well as the moderator and online participants to turn on their cameras to join the online photosession. Again, we would like to invite all the keynote speakers, moderator, and also the online participants to turn on the cameras because we are going to have online photosession. So the photosession we can count down. 3, 2, 1. Okay. Thank you very much. The keynote speakers and also the moderator, all of the participants. Ladies and gentlemen, now we come to parallelization. We will proceed to the parallelization. We will remind that please check your assigned Zoom breakout rooms according to the parallelization schedule. We will remind that please change your display name using the former panel room name dash your name as well as your university. So this is also the general reminder that we will select the best presenter. Therefore, all presenters are encouraged to be active, such as attending all sessions, including the presentation as well as keynote speaking session, and turning on the cameras. And lastly, actively asking questions in parallelization. So we wish all presenters and participants productive and also engaging discussion. I will close the first session. Assalamualaikum warahmatullahi wabarakatuh.
Bapak Ibu yang masih di utama, silakan cus atau sign ke rumah masing-masing sesuai jadwal yang sudah diberikan nanti.
Gak ada suaranya. PSP, FPK, Almatan, Sembayang, Cikarang, Again, I will check your voice clear. Hello. Could you hear my voice? Iya, suara saya masuk di mereka saya nggak bisa dengar. That's great. Okay, we'll start from there. Okay. On behalf of the seminar, first in sciences, engineering, and technology 2025. That is extended in today, 5/2025. The topic in the seminar is creating science, engineering, and technology for sustainable goals. So the first, let me introduce myself, and probably I'm only the moderator. Probably the next speaker also join with us. My name is Raffi, as your moderator in this room C. And in this opportunity, we will listen to 11 presentations, which is divided into 2 sessions. Yeah. So please, for all presenters, must remain in this room until the session ends. And then after the first session ends, we will back to the main room again to continue the next agenda, because we still have the main keynote speakers as well. Okay, so please, for all presenters, must remain in this room until the session at the end. And as organizing committee mentioned before, that each presenter will have around 7 minutes to talk. And then for the Q&A session will be guided by a moderator, by me, after 3 or 4 presenters finish presenting. And for the papers, around for Q&A session, we will hold for 3 minutes. Yeah? Okay? Okay, we will start for our seminar, yeah? Okay. For the first presenter is Miss Putri Nuraini, and the title of the presentation is Catch Composition and Population Analysis of the Main Cats, Bycatch and Discard from Gombang Fishing Gear in the Meranti Island. So for Miss Putri Nuraini, please share your screen and time is yours. Or Miss Putri Nuraini with us? Hello? Putri Nuraini, can you hear our voice?
So that our session
You are still in mute.
please throw your camera on position. Jadi harap nyalakan kamera setiap presenter. Kedua, kindly remove your display using Number 3, please keep your microphone unless you are permitted to speak. Jadi nanti harap matikan mikrofon kecuali
Okay, could you start your presentation, please?
Oke, selanjutnya it's presenting as 7 minutes for presentation and our session. Presentasi dan 3 menit untuk diskusi. Selanjutnya to Jadi setiap
balik dulu ke utama.
apakah ada pertanyaan?
Balik supaya sari.
Meeting,
Tapi lagi aja.
Mbak bisa lanjutkan?
To have excellent presenter as today.
Oke, and then record aja.
We will
Kasih dulu.
Reset.
When I call your name, please drop your on camera, share your screen, and get your presentation. Oke, yang pertama saya akan mengambil presenter Putri Nur Ayu dengan judul presentasi Cats Composition Analyze Cats by Cats and Describe from all countries in the Maranti Island. Pada mulai silakan waktu dan tempat dengan durasi 7 menit. Oke, sorry diulangi lagi ya. Yang pertama dari Bapak Hendra
Udah belum mereka presentasi?
belum. Penelitian tentang riset and development of a popular STEM modul on sustainable development goals for 2010. Kepada Pak Hendra untuk sertifikat untuk selama 7 menit.
Bantu nilai mana yang oke ya? Satu menit lagi. Satu. Miss Putri, sorry, your time is 1 minute left. Please go ahead. Putri Nuraini, and the next we will continue to, I would like to invite the next presenter is Miss Hotreni Nelka Sihombing, and the title about the analysis of the mancats and bycatch composition of gombang fishing here in the Anak Setata water, Meranti Island. For Miss Hotreni, the time is yours.
Thank you for your presentation. We will now continue with the next presenter is Miss Elma Susani. Miss Elma Susani. Yeah, can you start the presentation? The floor is yours. Thank you very much.
Hello, Miss Hotreni, are you with us? Sorry, we can't hear your voice.
Thank you, Mr. Rizky. For the next presenter, Mr. Juwali Muhammad. Okay.
Sorry, Miss Hotreni, can you slideshow your presentation?
Okay, thank you. Your music. Okay. We will now have a discussion for Q&A segment. If you would like to ask question, please use the raise hand.
Speech will by Professor Hans Stiller from University of Würzburg, Germany.
Recording stopped.
Speech will be delivered by Associate Professor Dr. Chris Antonopoulos from University of United Kingdom. So this session will be guided by our moderator, Dr. Zulkarnain. Now, I would like to hand over the session to the moderator.
All right, thank you. Good afternoon, everyone. This is Professor Hans Stiller. How are you?
I'm fine, thank you.
Yeah, it's a great pleasure. It's an honor for us to be here with us. This is the second session of speaker. In this session, we are going to have two different presentations. That will be delivered, first one by Professor Hans-Stefan Siller from the University of Würzburg, Germany, and followed by the second presentations by Dr. Chris Antonopoulos from the University of Essex, United Kingdom. Each speaker will have approximately 30 minutes, and also at the end of the presentations, at the end of the second presentations, there will be a joint Q&A sessions. So if any of you have any questions during the presentations, feel free to post them on the Q&A box at the bottom of the screen. And also please remember to mention the name of the speaker to whom you are addressing the questions. So again, thank you everyone for joining this seminar. Now I'll pass the floor to our first speaker, Professor Hans-Stefan Siller from the University of Würzburg. He will talk about the mathematics, sustainability, artificial intelligence. Professor Siller, the floor is yours.
Thank you very much for this kind invitation, and thank you very much for having the opportunity to share my ideas with you. So it's a great honor to be with you, although it's a little bit late, a little bit early in the morning here, but that's fine. So I'm sharing my screen here at the moment. Just a second. I hope you can see it right now. So my talk is about mathematics, sustainability, and artificial intelligence, and I thought it would be good to have an idea about reflecting the challenges, potentials, and opportunities of the socio-ecological in mathematics lessons. So before I will start with this talk, I just want to show you where I am situated, as I guess Würzburg is not well known in the whole world. So just a small input, where are we now? What you can see here is a map of Germany. And Germany is not that big as Indonesia, as I realized last July when I first visited Indonesia. But we have 16 federal states, and you can see those 16 states presented with different colors here. And we are in this very southern part called Bayern or Bavaria. And Bavaria is more or less famous for some very traditional clothes. So we have kids running with so-called Lederhosen, which is part of our culture, but this is just a little bit of joke, as we also have a very big and rich culture and very beautiful sites, as Siba will tell you, because he has been here for some months already. And I just bring in some pictures what we are more or less proud of. So what you can see here is the scenery of Würzburg with the fortress and the river Main. And what you can see here is the so-called residence, which some of you maybe know from the Hollywood movie, The Three Musketeers, because it was a famous site where this movie was taken. And of course, we are very proud of our grapes here, because the people here drink or like to drink wine in this very special kind of bottle. I'm not telling the wine, I'm just presenting the bottle, which is unique to Würzburg, because this so-called Boxbeutel can only be found here and in one region in Portugal, all over the world. But to be honest, this is not the most important part about Würzburg. We have a very long-lasting and traditional university. And I just want to present it to you in very short. So this is our main building where our authorities are situated. And what is Würzburg famous for? So we have 11 Nobel laureates at the university. They are not living any longer, but they have been working here. And the most famous one is Konrad Wilhelm Röntgen. So he found the X-rays here in Würzburg, where he got the Nobel Prize for. And this is just to give you a small impression about this university, which is the 8th biggest university in Germany, with some guys who has done some interesting research for the whole world. And I am right now the chair of mathematics education, doing research and teaching for pre-service teachers. And I just want to bring in a small idea, what are we doing here? We are trying to implement
Recording in progress.
In math and for math education, where we are developing those concepts based on evidence and evaluating them in the long term. I am the chair of this section, and I have 2 colleagues who are accompanying me, Professor Hennecke, who is the professor for computer science, and a young researcher professor who is doing tertiary education. We are indeed very successful in funding, so I have a lot of projects running. The most latest one is the so-called Dimension project, where we are developing tasks for sustainable development. And of course, we want to do a lot of different things, which Setra has already seen. And if you're interested in that, I'm happy to invite you to Würzburg to get an impression what we're doing here and to work with us. So this is just a small insight into what we are doing, and now I want to come to my talk, because what is motivating me here is also the so-called disruptive events, which we are all realizing that they are indeed happening through different things. So I have brought some pictures from news media paper, which can be a little bit odd, because what we are indeed facing here are floods. We all know that we have this long-lasting war between the Ukraine and Russia. We all know that we also in Germany, although we are one of the richest countries in Europe, are facing poverty, and we all know since the pandemic that medical treatment is not a trivial thing. And why I'm telling that, or why I'm taking this up as a motivation for this talk, well, the UNESCO has defined the so-called 7 Sustainable Development Goals. And for me, those Sustainable Development Goals are very important for mathematics education. So as we are doing a lot of research in this field, the German Ministry of Education, so all over the whole federal states, I was asked to write a concept for bringing in sustainable development and sustainable development goals into German mathematics education. And I was very happy to do that. And this concept has been approved recently, and now we are working with that in schools. And this is coming through my background. So originally, I'm an Austrian working in Germany, and I was very keen in doing sports, in going into the nature, and my motivation always has been, am I able to explain the nature or our real world by mathematics? And indeed, this is possible. So this is my background, which is called mathematical modeling. And mathematical modeling has a lot to do with those disruptive events, and has a lot to do with artificial intelligence. And why I'm telling that? Well, if we have a look at models and at scenarios which are trying to simulate some of those disruptive events which I've mentioned, for example, the spreading of a pandemic, or the developing of poverty, or how can the war extend, or whatever. A lot of models are using, in the meantime, artificial intelligence, as artificial intelligence is part of our real life in the meantime. And for this reason, I wanted to combine artificial intelligence and sustainable development within mathematics education, as I'm very convinced that we have to teach our future, our young students, that they have to be critical about artificial intelligence on the one hand. They should take the chance of taking up artificial intelligence on the other hand, and they should be aware that they have to work through sustainable development goals and take up these chances to save our and their future life. And for this reason, I want to first disentangle those both terms, then try to combine those concepts in a way that we can see how can it be implemented in education. I want to show you one example throughout the case study we have done with German students here, and will conclude and have an outlook. So let's first disentangle those both terms, artificial intelligence and sustainable development. Well, As I have already told, AI has become widely known in recent years, thanks to AI-supported chatbots such as ChatGPT from OpenAI and Gemini from Google. However, the term artificial intelligence is by no means a new concept and is not limited to ChatGPT or similar technologies. The term artificial intelligence was coined in the 1950s when computer scientists came together to explore how machines could be made to mimic human intelligence. Those researchers proposed that machines could be engineered to think, learn, and solve problems. And those so-called machine learning algorithms came up, which are forming the basis for these generative AI systems to create new content based on large amounts of training data from which typical patterns are derived nowadays. And those large language models are now systems for generating text trained with huge amount of data to reproduce common word sequences and predict which word is likely to come next. There is a lot of math behind it. I will not address this at the moment. And if we disentangle the term sustainable development, well, then we have to be aware that there is a common definition of sustainable development, which is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And integrate environmental, economic, and social sustainability into political and economic decision-making processes. So you can see this is a very broad definition where our common future can play a central role due to being aware that we can influence the environment, the economic, and even social issues by the help of mathematics. And a key aspect of sustainable development is integrating these three pillars into political and economic decisions. And therefore, we have to take into account a social ecological approach which emphasizes the interconnectedness between social and environmental dimension. Of course, this is often overshadowed by economic interests, but we have to put that aside when we are dealing in education with those issues. So when I'm talking about those terms, AI and SD, within a mathematics education perspective, we can realize that mathematics education does not only has the task of imparting knowledge and skills for the future, but also plays a central role in shaping how mathematics will be perceived by society in the future. And our education system, or the education system in general, allows us to treat both topics separately in mathematics lessons. So you can do math about AI and math with AI. You can also talk about SD by the help of math, but you can also use math for bringing in SD topics into math education. And at the same time, we can therefore highlight opportunities for linking them. So if we want to see both sides, we can welcome artificial intelligence and its potentials to solve global challenges. Others are very concerned about the potential ethical, social, and environmental challenges of AI. And on the other hand, sustainable development issues have triggered a wide range of different perspectives. Some consider current measures to be insufficient. Others believe that they are heading in the wrong direction or even deny that any action is needed at all, which can be seen by some politicians who are very populistic orientated, which we are indeed facing in Europe and which is concerning me a lot. So therefore, we can state that an unbiased, constructive view of AI and SE seems essential in order to realistically assess their potentials and limitations with regard to socio-ecological issues and to act on this basis. And for this reason, I want to combine both concepts and show a way for educational implications in math education. So if we have a look at the potentials of generative AI for sustainable development, we can state that there is an increased productivity and optimized workflow. So a survey in 23 from Lane et al. Showed that more than 80% working with AI stated that AI had improved their performance at work, and more than half of the respondents reported greater happiness and mental health. This is one study. You have to be careful about that. Another potential which we can see is that new innovations overcome global challenges. So I have found two studies by Chen et al. And Olavade et al. That showed that AI models are helping to combat climate change by increasing the efficiency of energy systems, or in the era of global health, AI accelerates drug discovery. This can be helpful, but this also brings some ethical issues with it, so that you have to be careful about that as well. And the third potential which I identified is that we can talk about inclusion and individualization by using generative AI for sustainable development. So AI supports learners in underserved communities and enables people to gain increased independence and control over their educational and career journeys. This has been shown in 24 by Johnson and Davis. If we talk about those potentials, we also have to talk about challenges, which can be seen when we use generative AI for sustainable development. First of all, the biasing. So if we talk about bias in IA systems, we refer to systematic errors that arise. Among other reasons, when algorithms propagate social inequalities contained in the training data, which is shown by Navigali et al. In 24. AI models are likely to repeat mainstream beliefs which could reduce the plurality of viewpoints. Biases may therefore reinforce discrimination in relation to gender, ethnicity, minorities, and disadvantaged groups, and serve to exploit minorities in weak positions. So you can see you have to be very careful about that, as this is a very big challenge. Another very big challenge is the lack of transparency. AI systems are black boxes, and it's very complicated, if not impossible, to explain how they arrive at a particular result. This lack of transparency and accountability is particularly problematic in areas where the stakes are high, such as healthcare. The lack of oversight accelerated by proprietary closed source models that limit external scrutiny. Another challenge which we are facing is the ecological impact, which we also have to be very aware, especially when we're dealing with sustainable development. The training and operation of AI models consume considerable amounts of energy, and interaction with large language model is estimated to consume 10 times as much power as a normal Google search, as Ries has shown in 23. Due to the enormous energy requirements of AI, it is predicted that access to energy could become a major bottleneck for its development in the 2030s, which is so shown by Goldman Sachs in 25. Another challenge which we have to be very aware of, especially in recent times, is misinformation and hallucination. So generative AI systems can provide inaccurate but plausible sounding information. This phenomenon is referred to as hallucination. False information can, for example, concern critical health issues where AI could give patients dangerous advices. Misinformation can also be deliberately disseminated for political or financial gain, for example, by spreading so-called deepfakes, which is shown by other scientists. And of course, we have to be aware of the digital divide. So this is the last challenge I identified, because AI or the benefits of AI are unevenly distributed despite its many possibilities. So disadvantaged regions may not have access to necessary technical infrastructure, widening the global digital divide and concentrating AI wealth in a few economies and companies, which is a concern formulated by the UNESCO in 23, and I guess it's very actual at the moment. So overall, the potentials and challenges presented here, they're underlying a correlation between AI and SE. And this conjunction is particularly relevant to education, and that's the reason why I want to interweave AI and SE with education. When addressing SE in education, it's not sufficient to view the SDGs separately, as this ignores the interlinkages and tensions between different SDGs, which could lead to unbalanced, isolated approaches that disregard other perspectives. AI technologies might accelerate this one-sided, isolated view to their reliance and training data, which we have seen as a challenge called bias. At the same time, generative AI systems allow the user to counteract these tendencies through explicit prompting, which is a very important acting when dealing with AI systems. Even more, so one-sided views presented by generative AI can encourage the educated user to rethink both the pitfalls of AI systems and perspectives on SE, as well as their conjunction. To enable students to perform this critical reflection, it's essential that they both understand theoretically how AI systems work and how their deficiencies arise, and that they acquire skills for responsibly using AI in their educational processes. So we have done some work here at my chair by Alisa Fock, and of course the UNESCO has shown here a lot of different things. So if we interweave AI and SE with education, we can and should be addressed from various starting points. However, ESE is often limited to the teaching of environmental scientific knowledge, while the social domain is underrepresented, which dismisses its perceived importance and relevance. So AI requires teaching that goes beyond factual knowledge to achieve this theoretical understanding that serves as the foundation for the understanding and asserting agency and responsibility. As well, it's necessary not only to promote the acquisitions of appropriate skills among students, but also to recognize the need to engage with the topics of the SDGs, to use AI safely and responsibly, and to acquire an individual attitude based on scientific facts. This includes not only knowledge and skills, but also motivational and social aspects, which is very important in terms of math education. So if we interweave this in education, we can achieve a goal of empowering individuals of all ages to make well-informed decisions and actively engage in personal and collective endeavors that foster social transformation and environmental accountability, as well to engage with AI in a critical way that promotes inclusivity, human accountability, and responsible citizenship, which was developed in the UNESCO competency frameworks for AI and SD, which can be found on the website of the UNESCO. So since these frameworks are rather general and cross-curricular, we must ask ourselves, how can we bring this together with math education? And I bring you some small points or questions which arise to me. So, to what extent can SD be addressed in classrooms? What contribution can education make to SD? What are the limits of education within AI and SD? And to what extent does teaching need to change? Likewise, questions arise regarding the implication of AI. So, to what extent can AI and must AI be addressed in math classrooms? What contribution can AI make to the quality of education? What are the limits of AI for education, and to what extent does teaching and learning need to change in the light of challenges that arise by AI? So if we want to answer those questions, we would need another 2 or 3 talks for each of those questions. I just want to show you some sort of case study we have done where we were addressing those questions and where we took up the idea of prompting and created a task by a certain prompt we arranged in the context of sustainable development. So we have these documents which is called prompt task creation, where we have put in the range of grade levels and some task criteria and some prompts which are necessary that a certain task is developed. And we also put in the curriculum, in our case from Bavaria, where we wanted to create the task for sustainable energy for grade ranges 8 to 10. And of course, when you're doing something like that, you have to be aware that we have some expert specification and main prompting in the first part. We have the curriculum, as I told you already. We have the task criteria, which I already told you. And we have 4 example tasks, which we created by ourselves so that the system has something to learn. And then we have given a description of what the chatbot, which was in our case Google Gemini, is supposed to do. And this can be found here. And if you have worked in those documents which are based on scientific facts and put in this prompt, read the prompt task creation first and then create a task for grade range 8 to 10 in the context of sustainable energy, a task will be developed. And what we identified is that this task is interesting because it, on a first glance, shows you can work on that. And it even goes further because the chatbot is also giving some data sources which you can use. But you have to be very, very careful at this stage and at this stage. So what we have found is that there is one correct link and one hallucinated link, which can be proved very easily. You just have to go to this rules and we'll see the first one will work, the second one will not work. But in terms of the task, you also have to be very careful because this task is not very good. If you try to identify errors in this task, you will identify a lot of those challenges I was talking about right before. And we had to put in a lot of effort to get a task which can be doable for students in school. So the final task by ourselves had to be reiterated several times. And we have done a lot of, or put in a lot of effort to get a high quality task that can be put into math education, which can be seen here. What we have used is data from the correct link, because this is data which is provided by the German government. And then you can work with this data in a very interesting way, so that you are doing some linear regression in the context of wind energy and wind speed, producing electricity for society. So this is just one idea which you could deal with, and where research is now working on how can we create tasks, how can they be theoretically funded, and how can they be empirically proved. So the first task, which was be created by my group and me, and at the end of my talk I just want to have a short conclusion and give you an outlook. So my conclusion at all is my present approach has enabled the collection of preliminary evidence that indicates the necessity for teachers to maintain a central role in mathematics lessons. AI-generated tasks must be revised despite their potential as a valuable starting point for task design, and alternative approaches to modify tasks other than the one I have demonstrated here can be employed. For example, educators could utilize data from the ENSO-E transparency platform, which is a special open access platform for gaining data, and modify the task description instead of conducting their own data searches. And if we have a look into the future, we can say that our results can be utilized to guide further prompt engineering. We have first retrieved content knowledge from the model and only then proceed with the actual task in the subsequent steps. The strategy termed generated knowledge prompting, and this has the potential to enhance the quality of output. Alternatively, first allowing the model to identify interesting data and subsequently utilizing this data suggests potential tasks, which mirrors the order in which humans typically approach task design in practice. And models could be prompted to generate a range of tasks, highlight their characteristics, and then select the most suitable one, thereby rethinking its own output. So what I tried is to demonstrate the potential for a future practical and research-based approach to teach math, which is considered, in my opinion, to be highly promising. And as we have now reached 5 minutes more than this half an hour you gave me, I'm very sorry for that. I want to thank you for your patience and for interest and attention. And you can see here my team. And as I said in the beginning, I'm very happy to welcome you in Würzburg if you're interested in our research and in working together. Thank you very much.
Thank you, Professor Stefan. It's a very interesting presentations. I believe that there will be a lot of questions from all of the participants, but we will keep it for later. Now we are going to move on to the next presentations. Our second presentation will be delivered by Dr. Chris Antonopoulos from the University of Essex, United Kingdom. Chris will be sharing his expertise on the topics, can we predict the future behavior of the system? This topic lies at the heart of modern applied mathematics, chaos theory, and also complex systems. And we are very much looking forward to learning from his perspective. Chris, the floor is yours.
Thank you very much.
Thank you very much, Zul, for this nice introduction. The highlights of this conference, which is amazing. And today I'm covering something that I believe is in the science and dynamic system. So I will predict the future. Practical examples, for example, when we want to be the next day or after a few hours, basically we're asking quite a mathematical question, which is to happen in the later with respect to weather. So if as a system, so we get basically more mathematical equations, and then we want to solve, and then it knows right what is going to happen in the future. So basically, we have all asked questions such as how much the weather will be in 5 days. The theory is that what is going to happen in this particular example, we're asking a question about weather, but we can replace this system by any other system that will change in time. And the most important question, I believe, which is prediction. So I'm going to go through some concepts that are coming from the theory of dynamics. So, for example, if we but instead no matter if we're expecting it to be, it will not go back to the beginning. So what we have to keep in mind is that when it comes to prediction, it's inherent science. Involved in the outcome of events. So it's not a definite science, and it's not a definite. So we have to assign probabilities, and in most cases, use some uncertainty. Because nowadays are because of the improvements in hardware and also software. Technology, the theory of deterministic chaos, shows that they will never be perfect. And that's what I'm going to highlight in my presentation today. There's no roundness in the development of them. Instead, the fate of the system is determined by mathematics. In most realistic cases, these equations are non-linear, and this is where things are becoming really very interesting, and chaos values. So a deterministic model will always produce the same output from a given starting condition or initial state. What stochastic system can do. So the weather is a large-scale phenomenon, and the way to model it and start what's going to happen, for example, tomorrow or after a few days, we can use some of the most important mathematical tools we have. Newtonian description of the problem, so we can use the development of it's quite well, but this is where chaos theory. The chaos theory points to the limitations of predictions even for deterministic Newtonian physics. Even if the system can be described by equations, with equations, and we can use Newtonian physics or other theories, it's still there are still limitations in prediction.
we're talking about is unpredictability, which is our inherent inability to predict for very long times. We can probably predict it for the next few days, so the probability of being right in our prediction is probably fine for the next. But if we're talking about what here, then obviously this probability. So even if we can come up with a prediction, we're not, it's going to be the right one. The reason for this is that the weather system actually is a chaotic system. Inherent unpredictability. Now, go through a brief historical about how the history came up, and it's everything started. And he was one of the first scientists having access to a mainframe computer at this time to solve numerically the equations of a dynamical system that was predicting airflow in the atmosphere. So he was able to derive mathematical systems described by systems, by equations, by differential equations actually, and he had access, etc. So he used his model with set of three ordinary differential equations for air convection. He programmed them into a room-sized computer that was one of the very first ones in the world, and he was able to compute slide. So he used initial conditions, and he waited long enough for, which is what we call an order, to be computed, and solutions like the one you see in the picture. So what he did was something that makes every chaotic system. He ran the system again a second time, but slightly perturbed the initial conditions. Slightly perturbed one of them and ran the simulation again in the same computer. He was expecting to find a solution that would be very close He was astonished to find that the program produced a radically different forecast. Or trying to find out if the bug or there was a mistake in his code, he couldn't find anything. The code but came across this very important concept that we know nowadays how to fix every field. He changed slightly the system and he obtained a completely different solution to the system. So the conclusion was that even for a simple deterministic set of equations, can yield a radical
Chris, excuse me.
Yeah.
Chris, sorry to interrupt. I think we have a connection problem here. We can't hear you clearly. So, would you like to try maybe turn off your video for a moment?
Yes, I can do that. And let me know if it is better. After
yeah, I think
is it better?
It's a little bit better.
Okay. Should I go through this slide again?
I think you can just go on with the last slide, please.
Okay, so what we just discussed of the system a radical different forecast. Come across this very important property of chaotic systems. So basically, his was a chaotic one. Said as the butterfly effect. So he did that extreme sensitivity to initial conditions meant the flap of the butterfly's wing in Brazil would set off a tornado in Texas. And this is the so-called butterfly effect, which is basically pioneered by Lawrence and other researchers, and has found widespread application as deterministic case. So basically, that is the concept of deterministic. A system that is described by equations. It is exhibiting sensitivity to initial conditions, so outcomes actually of the system of the initial condition, and this gives rise to the so-called emergence of deterministic chaos in the dynamical system. His system is theory generated a very well-known phenomenon, which is called potential factor that we can see in to the right of the slide, which is basically the phase space of the system and of sensitivity to initial condition and chaotic behavior. And so motion characterized by sensitivity to initial condition. In practice, it means that question the point over here, specific, and if it is informed by the equations of the system, at some point we will not be able to locate the trajectory of the system on this attractor. Other way to characterize this attractor is by calling it a straight attractor. So it's the trajectories of the system, they become unpredictable. So this is why we use the word chaos. It comes from an ancient Greek word chaos, which and that's actually the word that was used initially and the development of this theory to characterize systems with sensitive dependence on initial conditions. We can think of it as a dependence on initial conditions, and it's impossible to predict in the long term. So basically, that's the most important property of this, and that was presented by Lawrence and defined. Now, the characteristics of chaotic behavior are the following, and it's deterministic, so chaotic systems are completely by sets of equations of motion, as opposed to image-sensitive dependence on initial conditions. So any perturbation, no matter how small, will alter the future behavior of the system. Chaotic systems, so will always refer to the local region of the point of the trajectory. So eventually, if the wait for the system to evolve for very long times, it will actually visit the chaotic space, every point in the chaotic space. Embedded in the phase space with number of unstable periodic columns. So, what about the mathematics? So I'll just move on to the next slide, which is describing the famous Lorentz equation that we used in the black it's about 1965, the Lorentz system, which is described by three ordinary differential equations with variables x, y, and z that depend on time t. Comes with three parameters, sigma, r, and b. So these are the well-known Lorentz equations. Now, if we look at certain third equations, they involve quadratic nonlinearities. So this system is actually a coupled system of three nonlinear to solve analytically. So the only way to understand the behavior of the system is the system numerically, a computer. And from those trying to understand what the future behavior of the Lorentz. So this is again a classic example of a deterministic system. So the fate Y and Z, which describe three dimensions, right, are actually, if they're simplistic and deterministic, they sensitive dependence on initial condition. So at some point, they become unpredictable. Now, we can study this system mathematically for reduce the and b, for example, by setting sigma to 10 and b to 8 over 3. Data static below the earth. So we try here parameter values that are related to the very R, keeping sigma 10 and b equal to 8 over 3, and see changes in the behavior of the system as we change R, the third parameter in the system. So we can go through the so-called stability analysis, defined as the critical points, which where the solutions are time. We can do that by setting first the equation equal to 0. Constant in time, and we can identify three critical points that we call them P1, P2, then on the R variable, whereas the first one, P1, is the origin. So next we can study the behavior and extract how the system behave near these critical points. And depending on find out that the system indeed conditions, so there is a critical level where even though the system is and the solution is completely conditions, it exhibits sensitive dependence. In this example here, I have computed the solution to the Lorentz initial conditions. I started with my reference initial conditions set at the point 555 in three-dimensional space, then computed the solution, so that is shown in the figure by the blue solid together, and then first initial condition 555. So I just perturbed the first component of the initial condition and set it to 501, choosing as the null value I equals 38, and then plotted the solution to the system again. to the system. And that is shown in the figure by the, so as you can see here, the two solutions look virtually the same up until about time t equals 10, after which they start deviating from themselves. But you can see here the blue arrow is pointing to the first point, time point where the two. So this is a sample of chaotic trajectories. So by perturbing slightly the initial position and unexpectedly start deviating from each other. And this is actually what Loris saw in his seminar experiments that were published. So Lawrence concluded by this example that detect long-range weather predictions are actually not possible. That was a revolutionary idea back in the 1960s, and there was a belief amongst that if we were able to solve questions of a deterministic system, able to predict the future behavior of the system. That was also driven by observations about the motion of the Earth and other planets. But with his example saying that actually that is not true. So it was around in the 60s about chaotic systems. Now, of course, there are more by the system, but I think the most important one is the so-called stage attractor, which is basically a set of attractors in the phase space of the system, which exhibit chaotic behavior if we compute solutions out there. So this is why we call this attractor arterial. It describes an attractor that exhibits chaotic dependence on initial conditions. So I'll just go through this again of the so-called Lorentz attractor to the right of it. And the two figures to the left of the slide show just two different projections of the slide. Now, I'd like to discuss some implications related to numerical computations, to initial conditions, as implications for numerical computation. I think the only way to study this described by ODs is by solving numerical computing. So step sizes, different numerical acronyms, or even if running the same algorithm on different computers, eventually will introduce small differences. Will lead to large differences. However, the general opinion are independent of this. Other types of, for example, intermittent bursts of chaotic behavior separated by long intervals of relations, which demonstrate that in general systems of nonlinear can exhibit very behavior that which is from forecasting their future behavior. So chaotic behavioral solutions appear to be more common than expected at first, and still unanswered, and that is basically the reason why there is still ongoing research taking place in our attempt to predict the future behavior of these systems. And this is based 10 years or so by developments in data science, and in particular, particularly so the so-called predict useful models, so-called machine models. One of the examples that machine learning methods can be used is weather systems. So basically, technologists must consider many phenomena when it comes to weather prediction. These are covered for various factors. For example, will hit the Earth's surface, water changing phases, etc. They even must consider the effects of the Earth's rotation in space, and so many other factors if they want to model weather systems. What you know is that small changes in any of these variables can affect the weather in unexpected ways. So Lawrence work led to improvements in weather forecasting, but still demonstrated that predict for very long time. Nowadays, meteorologists use more advanced methods. Future, for example, they use several forecasting, which is basically running the same model using slightly different, and then averaging over the different initial conditions, probable outcome of the system. Actually, the forecast that we see in our weather apps, for example, in our mobile phone. So nowadays, data science has evolved so much that offers us another perspective, another way of trying to predict systems, and that is coming from the development of machine learning methods, the concepts, and in different fields, then systems in a way to the system in the future. Machine learning the method that teaches computers to do what comes naturally to humans and humans learn from experience. Methods to learn information learning. Now, relying on the equations that govern the system. They're ignorant of the equations of the system. They just the system to attempt to predict the future behavior. Right, so they usually use machine as a computer power to improve performance by studying or learning from data sets, and general technique they use to successful, and especially when it comes to artificial. One of the most prominent machine learning methods an approach to make machine learning algorithms run faster and learn better, and they actually use ideas coming from dynamical systems theory, and in particular they use specifically to improve and forecast the quality of the prediction they offer. So when it comes to this kind of system, machine learning method, usually the dynamical system can be used by a mathematical function that describes and having knowledge of the system, computing position of the system in time and also in space. Now, in our book,
first message, we are working on chaotic prediction, and in particular, we focus on the low-risk system that I described before, and we different machine learning algorithms to predict the future behavior using algorithm in a way to demonstrate that applications can clear and challenging machine learning prediction system for a number of in the future, but what we want to do is that by using them for machine learning algorithms, at the moment, what example of a chaotic system in non-linear dynamics. So by using these methods and for machine learning algorithms multi-layer perceptrons, we show that still predict the future behavior of the learning system as we demonstrate here for quite long in the future. So the future by using the so-called lap of time as a measure, which is basically given by the a way to quantify how chaotic a system is. In our work, we have demonstrated that system far beyond by using traditional methods that are not related to data science. Our work is actually based on a paper here by Patrick and Al that was published in 2018, where they created that they can actually predict the future. A very model. It's got a lot of potential. And to use simple machine learning algorithms to do the same thing actually. I'll just go through slides here which demonstrate how the show for different systems that machine learning reserve probability can predict far into the future of the behavior of the system. The important thing about machine learning algorithms is that they actually know nothing about the equations of the system, and that is very useful. The reason is that we from different equipped with so many sensors that can continually record data sets and send them back to servers where these data sets can be processed further by machine learning algorithms. So we have actually the question nowadays is how can we study effectively or efficiently data sets which are as many data sets as we want if we want to study further the behavior. So in a nutshell, in machine learning, the equations are not important there. The only thing that is needed actually is, and this is easily obtained nowadays. So, one day we might be able to, whether a better and and that is supported by a what is describe other systems in nature. So it is a common belief in the scientific community nowadays that machine figured out actually how so it shows a lot of potential. It promises that we can actually predict for longer in the future by using this method. And making our lives easier and what the development of economy. So that brings me about the end of the presentation today. So thank you for joining questions. I'm happy to discuss them with you. Thank you.
All right, thank you, Chris. It's a very interesting presentations. Even though we have a slight problem with the sound.
Yeah.
So now we are going to have a Q&A session with both our keynote speaker to all of the participants. If you have any questions, please feel free to write it on the chat box, or you may also raise your hand to ask your questions directly. All right, we have one question here on the chat box. It's for Professor Hans.
Yeah, thank you. It's an important question. So should I answer it right now?
Yes, please, Professor Hans.
Okay. So the question was, why is it important to integrate digitalization and interdisciplinarity into modern mathematics education? I guess that's the first part of the question. So in my opinion, it's very necessary to show students how the real world works. So if we are educating, we are also educating for working places. And interdisciplinarity is one of the most important aspects when we look at our working places. So the whole STEM area is connected, interdisciplinary, and for this reason it's necessary to integrate scenarios, learning scenarios, which are addressing this interdisciplinarity. And we've seen that in the second talk, to some extent, that the focus of weather is connected to interdisciplinary aspects which can be described by and through mathematics. But solving the deterministic system is always challenging. So even very good students will not be able to do that on their own. That's just my opinion. And therefore, digital tools can support so that you are able to get a solution for very difficult interdisciplinary problems you're working on. And of course, you have to learn that. And learning that means you have to bring that into math education. And for this reason, I think it's important to integrate digitalization and interdisciplinarity in there. And the second part of the question is, what are the main challenges in integrating digitalization into mathematics education at university level? Well, I guess there are several challenges, and I am not an expert in the Indonesian university system, but if I address this question from a personal point of view, from a European perspective, I would claim, first of all, the biggest challenge is how can we integrate this digitalization meaningful. That means students have to realize that they need knowledge to critically work with digital tools. And for this reason, it's necessary to address this at university. So we have to have courses that takes into account the content knowledge and the knowledge about the digitalization in math. And for this reason, I guess this is one of the main challenges we are facing. I hope I have answered it.
There's another question in the chat box.
Yeah.
Also for you, Prof. Hans. How the integrations of AI and mathematical modeling could help solve global sustainability challenges, and what ethical considerations arise when using AI for sustainability, and how can mathematics address that?
So the integration of AI and mathematical modeling definitely can help to get an idea how a model can simulate reality. So I guess if you combine artificial intelligence with a model, you can simulate, for example, the weather forecast. You can simulate, for example, climbing a mountain. There you have concrete, or in the context of climbing a mountain, a discrete mathematical model behind. And if you put this model into an AI system, or even into a digital tool, it can help you to get a picture of, the path, although you are not keen in coding. So one can do that in coding. The other one can do that by using an AI system, as the AI system will be able to code itself. So for this reason, you can use the AI system, I would call it as an expert system, but you have to be aware, as I tried to show it. Of course, there can be failures, hallucinations, or whatever, so that you have to be very critical on the output in the end. And this is also some ethical consideration which you were asking. So being aware that such a tool can bring failures, is biasing, is hallucinating. This is one of the biggest issues we are facing. This is not a human who knows how we have to deal with that. So a mathematician is very rational. A mathematician is very keen to be critical on his or her own results. The system is not that critical. The system does only work, and this is an ethical consideration which you have to be very aware of.
All right, thank you, Prof. Hans. Next question, I think, for Chris. There is one question on the chat box, Chris. Would you consider aquaculture ecosystem, especially bioflux system, as practical example of Lorentz-type chaotic systems?
Yes, so that's a very interesting question. Thank you very much for asking this. We can model a system equation. So as long as there are quantities that evolve in time, and we can think of modeling this development in time by using, for example, what exactly we want to study, and can model mathematically a system, for example, in this case, a bioflux system. They can model it like Lorenz modeled the weather system. However, we have to be critically aware, as Professor Hans described, of the, for example, if there are linear terms appearing in the equations of the system, if the system is given by ordinary differential equations which are coupled, even if it is dissipative, even if it describes, for example, a byte system or any encapsulated system. So I would put more emphasis on the fact that we should critical the system and of the outputs of the system. It takes time and effort to model properly a system in a way that will be helpful. And of course, the model is always a rough approximation to reality. So there would be factors that we would not take into account. So this one will be crucial for the mathematical model of the system. So we don't take them into consideration. In any case, even a very good mathematical model is reality of nature. So that will bring about uncertainties in an ordinary differential equation. Therefore, where there are inner steps, then most the behavior of the system, which then relates the development. In a nutshell, yes, we can always model a system using ordinary differential equations or partial differential equations. The question is, how can we be critically consequences of the system? So I think that would be also a very important factor that we should always take into consideration. And as Professor Hart said before, a mathematician is happy to criticize their own and query whether they are correct. The model should be updated or changed. So I'm pretty scientists working in other fields of science are probably not so results that show probably so we really have to be very critical mathematical model and be aware that very interesting exceptional behaviors might the systems exist. Thank you.
All right, thank you, Chris, for the answer. We have another questions from the participant. Yahya Gunawan, please unmute yourself and ask your questions.
Okay, thank you very much, Mr. Zulkarnain. Thank you very much to Mr. Chris Antonopoulos for your insightful session. I would now like to address my question to Professor Seiler. Professor Seiler, thank you for your inspiring presentation. My name is Yahya Gunawan, a postgraduate from Padang State University, Indonesia. I am currently working as a research assistant with Mr. Zetra Putra, who was also my undergraduate supervisor. Together, we have been exploring various studies in digital-based mathematical learning, including computational thinking development, virtual tour, or augmented reality using Unity. I'm very inspired by your ideas on the intersection of mathematics, sustainable, and artificial intelligence. In my hometown, sir, Pekanbaru, the integration of AI-based and sustainability-oriented learning is still limited compared to regions like Java. I hope to further develop research in this area to bridge that gap and support more equitable access to technological innovation and innovation in education field. Professor, may I ask if your research group at the University of Würzburg currently offer international PhD or collaboration opportunities related to AI integrated mathematics education as sustainability, sir? And if possible, are there scholarship opportunities that support such as a research field focus? Thank you very much.
Mr. Yahya Kumnavan, thank you very much for this question. I guess this is a question which we can follow up afterwards as well. Zita has been here in Würzburg, and he knows the region very well, and he knows that we are eager to collaborate. And if you want to get some support, we will try to find interesting ways of supporting you, so that we can get into exchange. I'm definitely interested in bringing our ideas further and giving a deeper insight, because what I have shown you here in the talk was a first glance at what we are doing. So we have done a lot of research in the context of AI and math education in the meantime, as this is one of the hot topics, besides integrating SD, and I'm just trying to combine those different things. So I guess if you're interested in and get some support, just write an email afterwards, and we get into exchange, and we will see what we can do together.
Yes,
all right, thank you.
Thank you very much.
Any last comment, Yahya? That's all?
No.
All right, maybe, yeah, I think we are almost at the end of our sessions. And I believe there is no more questions from the participants. So thank you very much to both of our speakers, Professor Hans and also Chris. Thank you so much for joining today. We have heard two inspiring perspectives from both of you today, and it reminds us how mathematics continue to shape our understanding of the world and its future challenges. On behalf of the organizing committee, I would like to express our deepest gratitude to both of you for sharing your expertise with us. That concludes our session this afternoon. To all of the participants, please stay tuned for the next sessions, which will begin shortly after this. Once again, thank you everyone for your participation, and have a wonderful day ahead. Thank you so much. And now, I have an honor to returning the floor to our Master of Ceremony to continue with the next program. Thank you again. Thank you, Dr. Chris.
Thank you for this kind invitation. Thank you.
Thank you very much for such insightful presentation. Ladies and gentlemen, to express our sincere gratitude for their inspiring presentation, we would like to present the certificate of appreciation to our distinguished speakers and moderator. The certificate will be displayed as a token of our appreciation. So let us begin. The first certificate is presented to Professor Hans from the University of West Germany. And next, the certificate is presented to
Recording stopped.
Next, the certificate is presented to Associate Professor Dr. Chris Antonopoulos from University of Essex, United Kingdom. And finally, the certificate of appreciation is presented to our moderator, Dr. Zulkarnain. Thank you very much, everyone. But before we move on, I would like to invite all the speakers and moderator and all online participants to take some pictures. Please turn on your camera. So the photo session will begin in a countdown. 3, 2, 1. Okay, thank you very much, ladies and gentlemen, speakers and moderators.
Thank you.
Ladies and gentlemen, that's the end of our keynote session. So move on to the parallel session. We will proceed to the parallel session part 2. Please check your Zoom breakout according to the parallel schedule. Our committee will assist you in joining the respective rooms. We would like to remind you, please change your display name using this format. Panel room dash your name dash university. Thank you very much. I will repeat. Ladies and gentlemen, that is the end of our keynote session, and we come to the parallel session. So please check your assigned crop room according to the parallel schedule. And don't forget to rename your display name using this format. Panel room name dash university. So our committee will assist you in joining the respective rooms. We wish you all presenters and participants a productive and engaging discussion.
because we will appreciate active presenters and passive presenter in the main session as well. Okay. For the first session, we will present by Muhammad Rahman and Terjat Mr. Agus Syahroni. So without further ado, let's start our seminar for the first presenter. We would like to invite presenter is Mr. Muhammad Raihan Arfi. The title Definition of Light Color Difference during the whole process get results anchovies Helvoros SB for Mr. Raihan here with us. Okay, go ahead. Sorry, Mr. Raihan, your time, 5 minutes left. Please go ahead. Okay, thank you very much, Mr. Muhammad Raihan Arfi for the valuable presentation. We will continue with another presenter. Will be delivered by Mr. Agus Shah with the title Composition of 2-inch and 3-inch fill sketches at the mouth of the River. Are there Mr. Yes, please. Yes, the time is yours. Could you please mute for your one device?
Maybe I want to ask or it's the same, and then what how different what the put in another it's on the one I think that I should set trees and where Yes, please. Saya juga baru tahu ada baju.
Dia warnanya yang
Kaju is a different about the eucalyptus. Oh, it's the same. Okay, thank you. Interesting
for the valuable. Please go mute again. Okay, thank you very much. And I remind Mr. Agus if you have another devices on, please mute all and unmute with your devices with yourself, yeah, because we have a lot of start voice in here. Okay, we will continue with another session. We open the session. Please, is there any question? Please go ahead. You can use raise hand icon in your Zoom, and you can deliver directly. Is there any question for Mr. Agus or Mr. Muhammad Raihan? Okay. For the first from Miss Dinda Masyara, please. You can unmute by yourself. Very much. If there anyone else? Probably I will ask for Agus with research. In your research, you have a lot of gets and discard. Meanwhile, you have gets as well. My question is, based on your research, why you changes a lot of gets and discard spaces your treatment with the 2 and 3 entry on main size. What the main factors it becomes. Okay, that's all. My question for Mr. Agus. And then to Mr. Raihan, this time is yours to answer the question by Ms. Linda. Suggestions did that or it's enough? Okay. And for my question, please, Mr. Agus. I got a lot of star. You use the handbook or PC as well? Oh yeah. This is the problem. Okay, go ahead, please. You can answer with bahasa. It's okay, no problem. Oh, oke. I will again in bahasa ya. Di dalam penelitian Mr. Agus dinyatakan bahwa banyak sekali hasil baik dan selain main cat dari perlakuan ajaring 2 dan 3 inci. Kemudian bertanya kenapa bisa terjadi demikian spesies yang semakin banyak, sedangkan perlakuan yang dilakukan itu bergantung pada merekomendasikan tingkat selektivitas pada masing-masing perlakuan. So, the other question is, okay, apakah ketika proses perlakuan itu dalam penelitian itu dilakukan di musim tertentu atau ketika tidak musimnya? I got it. Thank you very much, Mr. Agus, for the answer this session. And we will, everyone, we will continue with another session presentation. We have two last presenters with Ms. Warham and Ms. Silviana for the last presentation. And we start for the first presenter is Become Believer by Ms. Warham, and the title Identification of Cats Fishing Gear in Daru Aman Village. For Ms. Warham, are you here with us? Okay, please go ahead. presentation is the last, so we'll continue for discussion session with what harmony, if there everyone have question, please deliver prayer. Okay, we have two question from Miss Patroni and Mr. Francis. Just the time is yours. Okay, you can answer directly or continue the next question. Is Rahani? Yeah. Okay, thank you very much, Mr. Rizky. Okay, you got this question for your presenters. You want to explain in English? It's okay. Okay, Ms. Hudson, the answer. Another opinion. Okay. For the next question. Okay, go ahead. Hello, Miss Soham, are you still with us? Miss Soham, are you still with us? Oh, it's okay. No problem. Please go ahead. Are you ready? Yeah. Mr. Rizky, what the important parameters consider our research site because your site is very close to the land area. If you connect your connection is you can turn off your camera. It's okay. Okay. we need it. Okay. Are you got the question? Okay. Pertanyaan adalah
Thank you. After that, you may return to main session. I feel confident that
Okay. How about Mr. Rizky? Are you have your opinion? Okay. Thank you very much. I think this is the end of our session. Thank you very much for all presenters for all the presentation as well. Before I close this session, on your camera, and we will take the photo session. And give us your smiling. Okay, I will count down with 3, 2, 1. Okay, time's up. 3, 2, 1. Okay. Thank you very much to all presenters. And on behalf of the seminar committee, I would like to say thank you again for your participation in this seminar. In the first Universitas Internasional seminar, I hope we can meet again in the next seminar in 6 years. I close this session with wassalamualaikum warahmatullahi wabarakatuh and good afternoon, bye-bye. And don't forget to return to main room because we will announce the best presenters in this room C. Okay, bye-bye, see you.
Recording in progress.
Ladies and gentlemen, now it's time for the announcement of best papers. This award is given to recognize outstanding presenters during the conference. After evaluation and discussion by the committee, we are pleased to announce the recipients of the Best Presenter Award. There are five presenters according to each room: A, room B, room C, and room D. And lastly, room E. Okay, we start from room A. The best presenter is Rizky Zakwani from Universitas Indonesia. Next, for room B, Miss Murshida Rama Nasution from Universitas Riau. Room C, Miss Dara Tri Handayani from Universitas Riau. Room D, Mr. Arif Solanbudi from Universitas Madura. Sorry. And lastly, from room E, Miss Riri Nasiri from Institut Teknologi Pelabuhan Indonesia. Once again, congratulations to our best presenters and winners. Honorable guests, as we approach the end of today's conference, we would like to invite the chairman of URICSET 2025, Dr. Zetra Hainul to deliver the closing remarks. We kindly invite Dr. Zetra Hainul to the stage.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Guests, esteemed speakers, participants, as well as our committee for this conference. First, I would like to thank to all of you who participated in this conference. This conference smoothly from the beginning, in the morning, till this afternoon. So we believe that this first Internasional Universitas Riau Conference Science, Engineering and Technology 2025 become our first conference where we can share knowledge and insight about topic science, engineering, and technology regarding to support SDGs, sustainable development goals, and also we have all nice speakers around the world, not only from Indonesia, but also Malaysia, and Germany, talk different topics, and also technology, AI, and also physics and engineering. It's very diverse topics. I believe that you get excited what they have discussed about, and also have a chance to other collaboration for the future with all speakers. Yeah, you can contact them, and I believe that are very welcome. As I have collaborated with some of them. So that's very good for starting point. So moving forward, I probably hope that the discussion and also change from the discussion of other group and also the speakers today and extend your knowledge and also your future research and also ideas for future career, as well as this become a starting point for us. And we hope that we can continue this conference. Today we organized this fully online, but we wish to do it next time. Be like more hybrid, where some of you can come join Riau, University of Riau, and so we can discuss directly and feel a connection, networking among the presenter and participants. Well, that's the end. And again, thank you for everyone. And after this, maybe we will inform you about the post-conference activity, especially how will we process possible publication. We look forward for that, and we will provide you some information, some other programs of this. So that's the end. We look forward to see you again for the next years. Not only online, but also to offline, face-to-face meeting. With this, I officially declare that URICSET 2025 close, and see you again next time. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Doctor, for your closing statement. And finally, officially conclude the first Universitas Riau International Conference in Science, Engineering and Technology 2025. Thank you once again for your active participation. See you again in our future conference next year. Assalamualaikum warahmatullahi wabarakatuh.
Tahu.